所以我有时候比赛，所以说一个结论不大。所以而且他没事情帮他们，所以我对就是这个是必须我是来的，是的。因为我到那个中心那个结论后，我觉得我放其他的我嘛，是的，比如说嘛，是的，这个操作，我思想，你觉得我都讲嘛，现在我不就是那个，然后他们是在人。不是那个算了，是，他们那个接受，是他起，然后上去是跟啊，不是那他说的一样，我不是那些人，是不是我？说吧，所以学生也是actually come and sit here. You guys are together. No, I'm a student. I'm a best student. Best student. Best student. PSK of India. Best student. Someone writes us together. Let's go into this place. This is someone. All best student. So do you want the practice is our mistake is the practice. Let's be honest. I think you know what single source single source means that we have from one person from the same source. Oh, so that is working individual. Yeah, so if your entire question has section A, B, C, D, or that one person only. Let's look at an example job performance, right? Which you can actually section A like what line standards and always declare by employee, but job performance you get from boss. Right? So this is two source. So if you only get a single source, then you find this. Oh, so that was it. I think it's one parents. When you go traverse, yes, basic and recognizing object area. Opposite and part of topic. Shop you drive back to see that. No, later on from the years. I don't think and okay. You like tonight, sit Bob. Yeah. So I no, I do. I was student coming. Today I got you some coffee. So which is the elastic complex. It's very acute. Teaching for six. This it's easy. Not with me. I'm running. Sudah selesai. No, I like it. You could have said to Bruno, I can't do so you are pretty much no, I think to go to oh, okay. It's okay. I think if you are doing it, it doesn't oh my God. He must Yeah, you use like the space.
Maybe that's not the wrong. Oh yeah, I think so. That was the thing. Correcto. Because
啊，对，这样，不可以，不可以，对对对对对，不能持一个月的，持3个月的，不能那么的，因为他不能哈，对。他都早。
No more already, is it?
No more.
No more already. Okay.
I 懂了，这个是
online can hear. Okay. Okay, good morning. Hopefully you have got down. Okay, we have the update for 4.1.1.7, right? You can just click update, they will update for you. So today we will be looking at a model like this. This is the model many people use, right? It's called latent variable modeling, where you have each variable measures with certain item. Okay, how many items is up to you. Usually people will use at least 2 items. Although 1 item can be used, many of your examiners will kill you if you have one item. Okay, they say 1 item cannot use. Okay, but you should tell them look at Joseph Hare's book. He has a variable with single item. You know, Joseph Hare's book, right? PLS primer. He has a variable called satisfaction single item. Okay, Hare okay, but you cannot. Why is it? Double standard, right? So he's a white guy, You're not. I don't understand the logic. The guy who you refer to, he has a single item. But they say, no, Malaysia cannot. Why is that? I don't understand that. There's actually a big literature on this. But unfortunately, many people are trained with looking at reliability, right? You need 2 items for reliability. Okay. For Cromba Alpha, you need 2 items. We have now a new reliability called McDonald's Omega. Cannot work with 2. You need 3 items. Okay? So if you are planning to use McDonald's Omega, you must have at least 3 items per contract. Okay? So this is the model we want to draw. After we draw this model, I will show you step by step how to run the model, how to record. How to draw table also I will show you, or else you will curse me for the rest of your life, right? This is Malaysia. In other parts of the world, they don't even show you how to copy paste, how to do table. They expect you to already know. Here we cannot. They're expecting you to show that, even to provide them with reference. This morning, somebody messaged, when you write EFA, CFA, right? You run all together, right? Can you give me a citation for that? I have to send them the citation. This is what's happening. They are already in the folder that I gave you. Most of the citation you need is already in the folder. You need to find them. Yesterday I showed you a paper by Bulan. It's a very good paper for reference for methodology. There's another paper which is very good by a guy called Green. These 2 papers, 2016, and then we have 2018. What they have done is they look at papers published and why they were rejected, and they list you all the problems. Some of them have very nice diagram. These 2 is very useful for your methodology section. So after we draw this model, we need to assess I will show you how to report 1, 2, 3, 4, 5. But first we need to finalize the model. Okay, yesterday we didn't have step 1, step 2. We only had step 2, remember? Was the relationship significant, not significant? Because they are single item. Single item, there's no concept of validity reliability. Once you have multiple items, we need to measure whether they are valid or reliable. That is why we will do 2 steps. So for most of the exercises, I will give you the name here. So to save time, I'm going to use only one data set, which is chatbot. So when we do another model, we just modify the original one. Because every time I do, people have problem holding the mouse. The mouse is running everywhere. So we have to do a workshop on how to control the mouse. So now I use one data set for all the analysis. To ease the modeling. So we have 3 variables here, 1, 2, 3, 4. So to draw very easy. First, in your SPSS, I like to clean our data using Excel or SPSS. SPSS is better because when you read SPSS file into SmartPLS, no errors. But if you convert to Excel and then you start reading, sometimes they give you some error message. That's why I prefer to use SPSS. EFA, yesterday I explained, right? EFA is you run all the items together. You are saying, I don't know. Okay. Are you doing that? You're not, right? Your chapter 3, you already write, right? I have this variable 3 items, this variable 3 items, this variable 5 items, and this variable 4 items, right? You already know, right? Maybe you did your proposal 2 years earlier. At that time, you know, but now you have amnesia, you forgot it, yeah? You already know, right? You should be running CFA. You want to confirm whether the item works. Okay? EFA is usually done for new skill development. That new skill development, you have many items, right? You don't know how many dimensions you have. You run, and then the software will tell you how many dimensions possible. That is the idea of EFA. Yeah? But unfortunately, if you are using SPSS, you have no choice. Okay? You have to do EFA. SPSS cannot do EFA, CFA. Cannot do CFA. Yeah? If you want to do CFA in SPSS, it's variable by variable. Cannot do all together. Okay? That's the difference. Here we can do all the variables together. And we are supposed to do all variables together. But the training in Malaysia is this. You will run an EFA for your independent variables. Right? You run EFA for your mediator variable. You run an EFA for your dependent variable. That was the training. And that's me smiling, right? I also was trained like that. I thought it was correct. Okay, you have a dependent variable with 4 items. How many dimensions do you expect? One lah. You're wasting your time, but we still run. So everything become one, right? This is a problem, lah. We never think also, lah. We just follow only, right? I also was doing that, lah. But when I started traveling to US, they were telling you cannot run them separately. Yeah? You're supposed to run them together. When you're running in CFA, right? You run all together, right? MOS. All the variable correlated, remember? All variable, independent, dependent, moderating, relating together. But why you are running them separately in SPSS? So that's why this paper is really good. This paper tells you should not run them separately. They are still teaching in some workshop, they are still teaching you how to run variable by variable CFA. That was like 20 years ago. I was doing that. So I have papers published like that. But I'm no longer doing that because now we run all variables together. That was many years ago. So that's why previously there's a requirement that every variable must have 4 items. Remember? That was those days because we were running one variable. If you don't have 4 items, cannot get fit values. 3 items is degrees of freedom is 0. No fit values. That's why they take 4. But now we run all together. So 2 items, 3 items is okay. Okay. No need to add more variables. So if your instrument has 3 items, just take the 3 items. No need to add to make it 4. Okay. That's the first thing. So when you enter your data in SPSS, you have variable names, right? Okay, variable names. This is my norm. Sometimes I want to throw water at my students. They have question 1A, question 2, 1A, 2. By the time I look at the number, I don't know what they're talking about. You like to do that, right? Question 2, 1A. Question 2, 2A, yeah? Have to go and look at the questionnaire. Like this, you can understand easily, right? This three variable usefulness. This three variable complexity. No need the questionnaire, right? You understand? You send to me also, I know which other item. Huh? Now, I work with some co-authors from overseas. Huh? I have to tell them, can you show me the model and tell me which item measuring which. So the coding is not the same. If I have coding like this, I don't need to look at the person. I can already know which item belongs where. So when you do this, they come together. When you read your data, they are all together. You can highlight and drag and drop. And that's the reason you should have the same name, but numbers are different. So 5 items right here, we have 5 items, right? I already know these 5 items work together. These 3 items work together. So we can drag and drop. That's the easier way to key in the data. Okay? Okay, so to plot the model in your software, yesterday, this morning I updated the software. Sometimes it takes a long time to download, so you can download anytime. Okay, we will start a new project. UOW2. So each project must have one data file and a drawing, right? Okay. So once you click the UOW2, they will give you this at the top there. They give you import data file and create model. The data file is named chatbot. Okay. So it is in the folder called. So when you click the import data file, this is the chatbot file, right? You see? Chatbot, nah? Software. Chatbot, right? I just click import. Okay. When you open this file, okay. When you open the file, you get like this, right? The only thing you need to check is this type of scale, right? You can also use ordinal, but all the items must be the same. You cannot have one item metric, 2 other item ordinal. Then they cannot mix together in one variable. Okay.
2 and 7. So the minimum values is 1. That's 1.
Okay. What happens is your scale is 1 to 7, but your respondent didn't use the entire scale. Many people answer only 3, 4, 5, 6, 7. So the minimum will be 3, maximum will be 7. Okay. This is one of the problems with many collectivistic culture. The answers will start from a 4, 4, 5, 6, 7. Okay. So they are not using the entire scale, right? Okay. In extreme cases, they only answer 6 and 7. Everybody answers 6 and 7. No 5, no 4, no 3, no 2, no 1. Also happens. Then what the software will do is they will convert to binary. Two answers only. You see the gender here. Gender is not binary. My gender is 1 and 2. But because 2 answers only, they convert to binary. Okay. Before you read the file, if you plan to do recoding in SmartPLS, they can do dummy coding, SmartPLS now. You need to click this down and change it to categorical. Okay, categorical, then only they will convert, they can convert to dummy. If it's binary, it's already 0, 1. Binary means 0 and 1. Okay, but categorical means 1 and 2. Okay, so only this item I will change. I can show you how to report later. Yeah, right. See here, I change it to categorical. Because now in SmartPLS, you can do dummy coding. You can also do reverse coding. You know, in your data, after you read your data, you don't have to do recoding in SPSS. Can do here. Reverse coding can do in SmartPLS. Dummy coding also can do in SmartPLS. I show you quickly. Okay. This is the file, right? Then you click import. Once you click import, you get all the data file. You see? Just click import. Okay, you get your data file, right? Okay. We have a variable called gender, right? This gender has 2 categories. One and let's say it's 1 and 2. If you want to recode, we have this function added new. This one. You can see this derived indicator. Okay. This is a function they added very recently. So you can do dummy coding directly in SmartPLS. You can do reverse coding directly in SmartPLS. No need to go back to SPSS. Let's say you forgot to reverse code. Remember? You need to go back to SPSS, reverse code, then come back again, right? You don't have to do that. Just click a button here, pick the item you want to reverse code. Let's say we want to reverse code. It is to convert dummy variable. So let's say you have male and 2 female, right? Okay. And they will create a dummy variable for this. Okay. 0 and 1. They will also create a variable for this 1 and 0. That means this variable 1 is for male. This variable 1 is for female. When you put into your model, you pick only 1. Don't pick both the categories. The other group will be the benchmark. Okay, that can be done. So if you click the recode, right? Reverse code, right? Okay. If you click the reverse scale, right? What they will ask you is which item you want to reverse scale. So okay, let's say I want to pick enjoyment 1, right? If I pick enjoyment 1, the new name will be enjoyment 1 dash reverse. Okay, dash reverse.
I do not have the reverse icon.
You have to go to derive indicator.
Yeah, I know, but derive is not there.
I think you have a older version. This is a recent one, 4.1.1.6. If you have the older version, they don't have that. You don't have? Derive indicator. You have 4.1.1.3. If you have a 4.1.1.2, you look like this one. Very recently, 3 months ago. 3 months ago. It's not a result. So this is recently. So you have a 4.1.1.2, you already say 3, 4, 5, 6, 7, 3. Don't have lah. You need to update. Okay, that's now, right? Here, right? You click this button, check update. They will tell you that the new update, right? But it takes some time to update lah. Okay. But that's only different lah. Okay. So you don't have to update yet lah. Later we can do that. You can start that. Okay. So this is the data file we already uploaded, right? Okay. It has 191 cases. If you have the student version, they will tell you have too many cases. Cannot run. Okay, the student version cannot run. 100 cases or below. This is 191, right? Okay. They will tell you have too many cases. That means you're not allowed to run more than 100 for student version. Okay. So now we have the create model, right? Just click the create model. Okay. When you click the create model, they will ask you what model you want to create, right? Okay. This is when you pick PLSM. Okay. After you do this model, later if you think you want to change the process, also you can convert. Not a problem. So this is the easiest one to draw. PLSM. Okay, when we click the PLSM, and we put model number 1. Okay, here we can put a name. We can also put 1, 2, 3, 4. Okay, if you put a name, then the name will come up in the drawing. But here I put 1, so they will tell you model 1. Okay, that's the only difference. So when you click save, okay, can you see? Yeah, if you look here, can you see now you have 2 files? One is your model. Can you see the PLN there? This is your PLN SEM model. So if you convert it to process, they will tell you process 1. They automatically understand what is the model you are drawing. Okay. Now we are doing PLS model number 1. Right? This is my data file. 2 files. We can have multiple data files in the same model. Not a problem. Okay, but you need to pick the data before you run. Okay. So this is the drawing we are doing. After we click this model, okay, these are the items you have. Okay, my recommendation is, let's say you want to draw a model, just keep the item you want to draw in one file. Okay. Or else the file will be very long, right? You have to scroll up, scroll down, scroll up. By the time you scroll up, you don't know what you're scrolling. So it's better to keep only the item you want to analyze in one file. Okay. Here I have many items because I have a combination. That's why it's long. Usually I keep them short. The model I want to analyze. So this is the model you want to draw, right? Okay. This is the model you want to draw. Okay. Usefulness has 3 items, right? You highlight the 3 items, you drag and drop. They will use the same name you already have. Your usefulness is somewhere here, right? Yes. 1, 2, 3. You highlight the item. Okay. When you drag, when you're happy, then click like over. They will have a variable here. Drag and drop. Okay. If you are not happy, you move until where you're happy, then you let go, right? So I have a variable called useful, right? I usually like to change the name. This is not a full name, right? Okay. This is the full name. Okay. Why I like to use the full name is later your report will show you this name. Okay. It's easier. Okay, finish. Okay, if your items are too close, okay, you see my items are like this, right? Very short, right? Okay, if you want to make it longer, just click on this. Then we have an arrow here. Can you see this arrow? They will make it normal length, yeah? So, I pull this and then I click here. They will adjust all items together. And then I want it to be on the left, right? Just keep on clicking here, right? Then you get it on the left. First variable, finish? Okay, now you drag the second variable and drop. You get the second variable. three items together. The items are together, right? Okay, the second variable is complexity, yeah? So just complexity together, then enjoyment and satisfaction, huh? Okay, we have this alignment, huh? So the alignment is matched, huh? So those are the four variables we have in our model. First, you drag and drop them into the canvas. Next, you need to connect. After you have all the four variables, now you have to use the button connect to connect, like this. This icon here, connect, and then we connect here. The color will change. And I change it with this black and white. So that it is black and white in here. Okay. So that's how you draw your model. After you draw, you have to click this button save. So that is already saved. This button. Okay. Yeah. As you have the concentration, I will save. Okay. If you modify the model, then the save button will become active. If you didn't modify the model, it is still the same. Okay. So this is how we draw our research model.
Yes. Left hand. I will move it. Oh, you can move it,
It's fine. I don't think this in this case. How do I feel select?
Okay, this bar here, right? You can make it smaller. So I am very short item, right? I have more space to draw because sometimes you want to have a big model, right? This bar here, right? You can pull it here so that it's shortest possible. Okay. So if you want to select the whole model, just press Control A. Control A, you can select the whole model. Then you can move the whole model together. Control A to select. Then use your mouse to move it around where you want. Yeah, right? I've already selected, then I can move it anywhere I want. But your select button must be on. Press Ctrl A, and then when you move the mouse, can you see the whole model moving to that? Okay. To reposition and all. You can do that. If you move one, you pull this, right? This one moves, that one doesn't move. But if you press Ctrl A, everything selected. Okay. Okay, let's say we want to hide some of this item. You can click on the variable, right click, then you can hide it. They will put a plus sign. Right click, hide. So sometimes your model got 20 items, right? One variable 20 items. Then 20 items cannot see, yeah? Everything's like that, right? So what we can do is right click and hide. Then they will put a plus sign. Like this, we have hidden the item for one variable. If you click, if you select Ctrl E, right? Everything selected, right? Okay, you can also use hide all together, alternate X. Alternate X. ALT. Yeah, there's a button called ALT, right? X. They will hide everything. ALT C is show everything. Okay. Guitar has the biggest model in the world. And the screen is so small, right? Item will overlap. Okay. So what you do is you hide one variable. You want to finalize, then you show again. Okay. Or else the item will overlap. Okay. To hide. No, just click outside. After you select, you don't want, just click here, it will go away. When you select all, right? You don't want to select, you just click somewhere, it will go away. No more selection. Ctrl A, okay, to select, right? You don't want to select, just click here, anywhere. This one will be no more highlights. Okay, let's start with highlight.
See the box here.
Left, right. Okay. If you select all, then you click this arrow left, right? Everything will move together. You want to move only one, right? Just click this variable and move lah. This only will move. The rest will not move. Left, right, top, bottom, right? Okay. If you select all and move, everything will move together. Okay. You press Ctrl A, right? Press Ctrl A and then you press this mouse, right? What will happen is everything will move lah. You're selecting all. Okay. So that's why we select only one and then we can move. Only one variable. So that's how the selection works. Control E means you select all. One variable by one variable, you just do with one. No need to do all. Okay, so that is how you can do some editing. Okay, yesterday I showed you how to change the variable from hexagon, octagon, right? Okay, we have also some examiners coming from different planets. So they will say why you are using hexagon. That's not the norm. I don't understand why. I want to draw circle, I want to draw square, I want to draw what? That is still a variable.
But they say that there is a meaning between the square and also the circle one.
No, that one is in Amos.
What do you mean?
In Israel, they have different meaning. In SPSS and PLS, that's it. They are just written there.
Okay.
In Amos, square boxes are actual variable.
Yes.
Okay, no item, right? One square box. That's why I said, if you learn Amos, you understand better. So here, everything is circle. Single item also circle. I want to do hexagon also can. There are papers published with hexagon. Okay, so not an issue. It is only drawing to show. This is how we can draw.
Why you need to update?
So once we have done this, then we need to analyze them. So to do the analysis, yesterday I already mentioned we have this five
The
steps,
SmartPLS is
right?
one or vice versa?
I'm going to do one at a time.
5G one.
See the five-step approach for testing the model.
Right, I mean, giving
Number one, number two, number three can only be done after you finalize your model. When you collect data, there may be some item not so good, right? We need to delete them first. Okay, so we will do number 4 first.
2 years now.
Okay, finalize this, then we start 1, 2, 3.
Huh?
Okay. Number 4 first, huh? Okay, number 4 first, huh?
Now they started to do the, I
Okay,
mean,
so number 4
modeling
is
already.
like this, huh? So after you have this model, we go to calculate. We will run these two procedure together. Algorithm and bootstrapping. Yesterday we did algorithm. When you run algorithm, the software will give you 3 values: loading, data values, and R square. Okay? Loading, data value, and R square. We need the loading to finalize the measurement. Remember? Okay. We need to write in chapter 3 what is our cut-off value for loading. You can use 0.5, 0.6, or 0.7 or 0.708. If you write in chapter number 3, my loading minimum is 0.708. Anything less than 0.708, you need to delete. 708, right? I don't use 708. I use 0.5. So anything less than 0.5, I delete. Anything more than 0.5, I retain. Okay, 0.5 to 0.7, we call them marginal loading. Not so good. But we can still retain them if your ABE is already good. 0.5. That is how we decide. Okay. Hence, suggestion is 0.708. Any loading you get less than 0.708, the color will be red. You don't have to delete. Okay. Those are indication only. Okay. So that's the first step. After we finalize that, then only we will run bootstrapping. Yeah. Okay. When you run the algorithm, they will run the algorithm, they will give you all the numbers, right? Okay. When you run the algorithm, you see all the numbers here. Okay. The first step is you need to finalize the loadings. Okay. You can start here, you can start here, or start here. Doesn't matter. Anywhere in the model. Let's say you look at the first variable, right? Any item need to delete. All of them very good, right?
Yeah.
This one, all of them very good. But here we have one item not so good, right? Okay. This item, can you delete this item? Click on the item and delete. Okay. Click on the item and delete. Calculate PLS algorithm first.
Okay. So
Let's start calculation.
Oh,
When we screen, I don't know what it is, but then they screen.
Yeah, mine construct. It don't make sense. If mine construct, one more just second, just like, it's going to be best in the room.
Oh, wait.
Okay. So now we already draw the model, right? You have the numbers, right? Okay. The first round of the decision is the loadings which are lower. Less than 0.5, we will delete. Round 1. Huh? Once we have deleted all the low loadings, then we will check CR and AVE. Composite reliability and AVE. If your AVE is still less than 0.5, you need to delete again. Because AVE is 0.5, then only valid. Less than 0.5, the measurement is not valid. This usually happens when many of your loadings are less than 0.7. Remember, yesterday I showed you the calculation. If you have 0.7, 0.7, 0.73 item, your AVE will be. So I cannot link it, so I show you. Okay, I have 3 items, right? Okay, I have 3 items. 1, 2, and 3. This is X1, this is X2, and this is X3. Let's say I have 0.7, 0.7, and 0.7. What will be my AVE? This is your loading. R, right? Okay. What will be your AB? R, here we have R square, right? 0.49, 0.49, 0.49. Okay, if you total this up will be 1.7147. Okay? Correct? You need a calculator? Yes, go ahead. This is your calculator, huh? Okay, 3, right? This is the total.
Okay.
Now I divide by 3, I get 0.
Okay.
Okay, you understand now? Okay, this is the calculation. Loading become R square average become ABE. This is equals to VE. VE is variance extracted for the item. ABE is the average. Okay? This is basic understanding, huh? Okay. That's why when you run your model, if the items are no good, your ABE will go down. People didn't understand your question. That's why they don't work together. Okay, so that's why we are checking this. Huh? So if your loadings are all below 0.7, you will never get ABE more than 0.5. But magically, many researchers have 0.5 ABE, but the loadings are no good. I will reject your paper happily. Because there's no way you can get more than 0.5 ABE if your loadings are not high. Minimum 0.7, remember?
Yeah.
Some loading can be 0.5, but another loading 0.9. They will help you to balance out. Okay? They will help you to balance out. That is why we need to understand this calculation. I've given you a template, remember? Yesterday I showed you ABE, CR, the first one. Huh? You can actually copy and paste any number you get from output, paste it into the calculator, they will give you the ABE and the CR.
So once the loading is below 0.5, even the AD is very high, you have to.
Less than 0.5, no good. Huh? Okay. I show you what happens. Huh? So we always claim 0.5 is good, right? When you have, this is the variable, this is your item, right? If your loading is 0.5, you square it, you get 0.25. Huh?
Yeah.
Is this the good item? This is a terrible item, right? You can only explain 25%. 1/4, not so good. Okay? 0.4 is 16%. That's a terrible item. That's why 0.5 also we are pushing our boundary. So that's why they cut off at 0.5. Okay, but you have a 0.5 and another item 0.9, they will help each other. Average will come back. That is why we must have some items which are high, some items which are low, we can still retain. Okay, the lowest loading in the literature is 0.4. If you still want to retain an item, 0.4, you can still do that as long as your ABE is already more than 0.5. Okay? Because more item better. So that's how the software is doing quite well. Okay, so when we delete this item, the numbers all will go away, right? Just delete this item. Your numbers all go away, right? Okay. So like that.
What about if the outer loading is less than 0.4, but
No, less than 0.5 you delete. More than 0.5 you delete. Then only we check again. Okay, now you deleted the item, right? The numbers all go away, right? So what will happen is every time you delete, the number will go away. Okay, now they have created a tool for you, so that every time you delete, they will automatically recalculate. So no need to do anything. So can you click the undo? Undo. Okay, the item will come back, right? Undo. Okay, the item is back. Okay, there's a button here. Can you see here? Oh, that's why you attend book. You don't explore. That's a problem. Just click this one. They will automatically recalculate. Okay? You delete, they recalculate. Delete, recalculate. So no need to run many times. Okay? Nanti ada apa manual syndrome. Okay? No, delete. Okay. Listen. I think many of you are listening wrong. Okay. Anything you want to edit on the diagram, you must click this button select first. Okay, if not, let's say you are here, right? You're on the connection mode, right? You click di sini sampai besok lah, dia tak akan keluar. Because you are in the connection mode. Edit, nah? Can you see here? I cannot right click delete, right? Okay. So what I do is I click this. Now I'm no more in the drawing mode. Now I can do anything else. This one will come. Okay. Tadi itu kita connection mode, nah? That's why cannot. Nah? So now if you click any item, they will allow you to delete. So you are already out of the drawing mode. That's why the select button is important. Nah? Okay. After you redo this button here, right? Recalculate automatically, yeah? So what happens is, they have already recalculated, right? Now if you delete this item, automatically they will calculate a new value. No need to rerun. Oh, banyak over. Okay, over. Delete it, huh? This item I delete, right? Now what happens is they recalculate already. New value. Okay, now they will give you a new value. Huh? No need to run 10.
If we run, okay.
Yeah. If you run,
Wrong.
oh, if you have many items, sampai besok lah. Automatic. Kalau macam ni tidak lama. This is what I see many different. You don't have the curiosity to explore, right? Klik sini, try lah. You don't learn without doing mistake, right? Click lah. Tak ada. You already save, right? You undo ni lah. They give you one button, you undo, right? 10 kali undo lah. Delete, undo, can. No worry.
Yeah, no. The item is low. You have to speak back.
No, okay, that's fine for you, sir. PLS also very smart, huh? Okay. I did that. Just now I didn't delete, right? I have a loading of 0.382, right? This one, right? How do you know it's low? If you go to the open report, can you click the open report? First you undo lah, so that then you can see this one. This is still back, right? When you click undo, this is coming back, right? Okay. Now you open your report. Okay. This is what we call like the output. They give you this links, right? Okay. Can you go to outer loadings? Outer loadings. Can you see a red color icon? Red color item. Okay. Outer loading. You see a red color item, right? Outer loading, right? Okay, bila senang-senang nanti you explore lah. Yeah, there are many things, right?
Yeah.
When you are free, go and click and see what comes up. So then you remember. We will do pass, final result and quality criteria, right? Can you see the outer loading? That's a red color item, right? That's a red color item, right? Okay, why is it red? Okay, no, not less than 0.5. No. Okay, the book called Hair et al. 2022, right? Okay, has it loading? This is the criteria. So any number less than 0.708 will be red in color. Okay? They follow the book. The book tells you ABE must be more than 0.5, right? ABE less than 0.5 will be red. Okay? Since he say loading 0.708, the software follow the number. Any number less than that number will be red in color. Red in color means you didn't pass. Green means pass. Okay, all the other items are green, right? I telling you all the other items are okay except for one item. Okay? But that's the same criteria. You want to see color or you want to see the number. Okay? So once we delete this number, the rest all will be green.
If you want it as a
No, 0.4 and above, we can still keep. 0.4 and above. But AB must be more than 0.4. Okay? But less than 0.4, no good.
Yeah,
No, if it is less than 50%, your measurement is not valid. 50% must be explained.
Of the one that the same is you keep 0.5. So you don't literature about that.
There's a lot of literature lah. Loadings less than equal to 0.4. This is more than equal to 0.4. This is the minimum. Okay, I usually don't do 0.4. I use 0.5. Okay, 0.4 is actually very low. So we keep only 0.5 and above. Okay, so this item we will delete. So we delete this item first.
From we use 0.008 because I threshold. Then there's no need for me to do any readjustment later on, right? Everything that is fine.
Okay. Okay, listen. If your loadings are all 0.708, no need to check anything. You will pass everything. Okay? But unfortunately, you don't get data like that. You don't get. Most of the time, you get some higher loading, lower loading. Okay, if your cutoff value is 0.708, you will end up deleting a lot of items. 0.5, 0.6, 0.7, all we see delete. If your cutoff value is 0.708. That's why we need to write them in chapter number 3. What is the minimum you want to hit? Okay. All to 2010, 2018 also same. Textbook. So there are many citations, like you can look at the literature. So for each number, they have different citation.
The one that you see in chapter 3 was by this part. So ada
Ada banyak template dah. I already give you sample pieces, right? I already explained yesterday. They will have everything, right? They will explain everything. This is the standard lah. It's quite technical. Remember, chapter 3 is quite straightforward. You have all the cutoff value, right? Sections are the same. Cutoff value only will differ based on the citation. You cite a different author, you have different number. I have a different number, but the flow is still the same. I actually teach my undergraduate student how to write chapter 1, chapter 2, chapter 3 with the sections. These are the sections you must have. So when they continue.
you must go to the point.
No, that one is when you do that. Okay, when you write your proposal, right? You need to write what you plan to do. What you plan to do. Okay. When you write chapter number 3 for proposal, I will do this analysis. After you finish chapter number 4, you have to rewrite chapter number 3 because you have already done past tense. Okay. Okay. My China student, data was collected. No? Now you're going proposal. Data already collected. No? Cannot. No? Data will be collected. Chapter 3. Once you finish data collection, you have to rewrite chapter 4. Data was collected because already collected. So that's the change.
It is the one you think after the proposal, you can delete your accident, you can bring back project.
Examiner will tell you lah, and then they smile. Okay, then the supervisor sakit. The supervisor sakit. I already tell 10 times, right? Proposal is present 10. After you finish part. Okay, we also have students who have proposal, but they have 5 chapters. Proposal, right? End of the chapter 1, right? Organization of the thesis, right? They have chapter 1, chapter 2, chapter 3, chapter 4, chapter 5. Then the examiner asks, where's your chapter 4 and 5? You copy it from somewhere. They just copy and paste. They don't even do this editing. I feel like this. So, 1, 2, 3 is proposal. 4 and 5 comes later.
Yes.
Okay? So when you're writing proposal, you have only 1, 2, 3. Okay? So in chapter number 3, we will write about the cutoff value. In chapter number 4, we carry it out. Okay? So if we say 0.5 here, sini 0.5 kena delete lah. If we say here 0.7, here 0.7 must delete. That's why we need the cutoff value to base. If you are writing a paper, don't have that like that.
Yeah.
When you are writing a paper, you discuss this under result.
Some people don't present the model.
Okay, but most of the general review will ask because without the loading we cannot see. Okay, we want to see a table, so I'll show you how it's done. So this is how you finalize your model. After all these loadings are okay, right? The loadings are all more than 0.5, right? Okay, that's first round. Then we need to know the ABE and the CR. Okay, now the software gives you move your mouse here. You move your mouse here, they give you ABE, CR, Bromba, everything, right? Okay, then you compare. Are the numbers okay? Okay, your mouse, right? Move your mouse here. Okay, you have the 4 values, right? All the 4 values, you have to check one by one, no? Okay, so they already give you the numbers, right? Okay, here they don't give you the color coding, no? But if you go to the output, they give you the color coding. Okay, this is your graphical output, right? Can you click the open report? When you click the open report, they will have a table called validity reliability. You see here, we have a table called validity reliability. And since you have problem with bigger than, smaller than, right? The software is trying to help you with the color. Your color, your number blind, you're also color blind, and God bless you lah. Level besar lebih kecil pun tak pandai lagi, ya. So dia bagi color merah dengan hijau kan. Merah means didn't pass. Green means pass. How do you know it passed or not? The number comes from the book. Hair et al. The book by Hair et al. He gives you loading must be greater than 0.708. AB must be greater than 0.5. PR must be greater than 0.7. Any number greater than a number green. Anything less will be red. So this is the color. This is already all okay, right? Okay. That's how we finalize the model. Okay. You can look at the numbers in your drawing. We can also check here. Okay. We have another table here called discriminant validity. Can you see this discriminant validity? Discriminant validity, yeah. When you click the discriminant validity, okay, there are here we have a few discriminant validity. Okay. We have this phoneme and laughter. This was used for a long time. This was developed in 1981, and now nobody uses them anymore. But yet, criteria has lots of citations. Phoneme and laughter 1981, but now we no longer use them. We only use this one, heterothread monothread ratio. Okay. This cross loading is also no longer required. But if you have to make your thesis longer, right? Like the below, right? Then you can present your cross loading. 3-4 pages, no need to write anything. Dia buka surat sudah save, tunjuk lagi. Tak perlu, this is no use lah. So this is the one we will use, this color. If you see here, we have a color coding. Green means less than 0.85. Green. 0.85 to 0.89 will be black. Black means not so good. More than 0.9 and above will be red. Red means fail. That's a color coding. Green, black, and red. Here we have a black, right? Is that? This is slightly higher than 0.85. So still okay. Once it's red, then only you have to justify. If it's more than 0.9, 0.9 and above, then we have to justify. Any question on the assessment? So first table, the convergent, this is called discriminant. The loading is, remember just now you saw the loading? That is called convergent, this is called discriminant. And these two together tells you your measurement is valid and reliable. Okay. Your measurement is valid and reliable, then only you can do the test. Okay. Okay. The other question I always get is my measurement model is very nice. But my structural model not so nice. Okay. I want to take water in myself. Okay. Measurement model is variable by variable. Variable by variable, right? Your measurement is okay. But when you do structural, it's variable to variable. Not the same. Okay. Measurement very good, but when you run your structural model, some of the variable may not be significant. Okay, so this is a different thing. First, we are looking at the measurement only variable by variable. For structural model, we are looking variable to variable. Okay, so why variable to variable not significant is when one variable go up, the other variable must move in the same direction. then only they will be correlated. Okay? One of the problems in many developing countries is when we use questionnaire research, right? Many respondents answer the same answer. 454545, right? Okay. And then your standard deviation will be very low. No variation. For research, you need variation. Some must answer low, some must answer high. Many people answer in the middle. Then only normal. Okay? That's what it is. Okay. So we have done this, right? Now, after we have done this, then only we start reporting. Before you do this, cannot report at all. Okay? This is what you need to pass.
What happened if the HTMT, you get a rank? How do we do
Okay, we have this equation. Let's say your HTMT is 0.92. Okay, your HTMT is 0.92. This will be rate, right? You did a pass. What you can do is you run good traffic. And 90%, then you look at the upper limit. It is less than 1, still okay.
It is, what is
If
it?
it's more than 1, cannot. That's serious problem with the measurement. Then we will look at the cross loading. The cross loading will tell you whether the item is loading high on many variables. Let me show you. Okay, here we have this cross loading, right? Can you see? Okay. This column, right? First column is a variable called complexity. Can you see the complexity? Okay. So this item must be high here. High here, low here. And this is called convergence. If you have a 0.9 here and another 0.9 here, it is not converging because it's loading on 2 variables, right? Okay. Here they are high here. These are all low, right? This is called convergence. It must be high here, low here. This is called discriminant. So the respondent understands this item belongs to complexity, not other variables. So sometimes you get this, 0.9, 0.9, 0.9. Then you will have a problem. Because the respondent thinks that item is measuring 3 different variables. This can happen. This can happen because respondent didn't understand the question. That is why you have many steps, right? In your study. I usually ask this question. Why are you doing your pilot test pre-test? Because my supervisor asked me to do. So all my strengths also. This is the reason. We are trying to determine whether the respondent understood the question you asked. And many people are still doing template research. Yeah? How do you do your pilot test? You send out 30, come back 30, you run SPSS, and SPSS telling you everybody understood that. Not true. SPSS is only telling you the answers are consistent. It doesn't tell you whether they understood or not. It doesn't. We have a term in psychology called cognitive interviewing. You know? Okay. Okay. So you can, yeah.
That's, she also read on her next. Yeah.
The point is the value on the diagonal. Okay, the value on the diagonal is supposed to be 1, correct? What they have done is they have replaced here with the square root of the AB. Square root of the AB, yeah? So the criteria is this number must be greater than all these numbers. Okay, this way, yeah? Okay, here we have left and right, right? Okay, this number must be greater than this number. It must be greater than this number. So if this number is 0.8 and you get a 0.9, they are not discriminant. Okay. Here we have this number against this and this, right? If it's higher than this, then it's discriminant. That's how the interpretation of Cornell law. But this one we no longer use. Okay. We will use the HTML.
Why?
Because this one always pass. That's why we have been using it for the last 30 years. For the examiners, the reviewers are also old school. Amos can only get this. In Amos don't have HTML. But if you follow the materials by a guy called Gaskin, right? This guy called Gaskin, he has add-on to MOS, no? They call it plugin. If you put the plugin, they will give you HTML. Okay? MOS don't have, okay? Only PLS have, no? So that's why this one was already criticized in 2013. Hensler wrote a paper saying that if you use this criteria, even the model wrong also you say okay. And that's why they run simulation. So this is no longer used. You will use the HTML just now. Yeah? Okay. For your,
Right, if I click on the bar chart,
they show you on the chart only, same number on chart.
what is green color? Does it indicate any?
There's no same.
The bar chart.
No, this green, right? Bar also will be green.
Oh, no, only one green. I click on the bar chart. The third one. Bar chart. Yeah, then only one green. Does it mean anything?
Oh no, this one is the high, this one is showing the correlation. That means high, this high means no good.
Oh,
This one is better.
break is better.
Because they are not highly correlated. They are not sharing correlation.
The previous HTML table that Prof to is now.
Yeah, it's
Has shown to us that the green color and one is black. So this one, no way is that.
no, this one still okay. This is less than 0.90. More than 0.90 will be red. That means you didn't pass. Okay. The science have be there. Okay, so
The next one to us near to 0.9. That's why it's
no, no, more than 0.85. 0.85 to 0.89 will be black. Okay. Okay, so you can look at this website called Qualtrics, huh? Okay, this is the professional data collection company, yeah? So for your pre-tech, right? I usually ask students, why are you doing your pre-tech? And then asking people, which is the 7 reasons, 7 ways to do the pre-tech. 7 ways, okay? But you only know one, no? 30 keluar, 30 masuk SPS, kan? Dulu ini dan selama, this is a problem lah. Nobody wants to change. That is one of them. They give you these 7 different ways, right? And then they tell you why you are doing. Can you see here? Number 1 is what? Top on the list. What is that? Okay. Where did you do this? You never did it, right? Number 1. You cannot 30. The 30 come back, you run reliability, right? How do you know the respondent understood your question? But still passed, very good. The examiner also same boat. This is the problem with our culture. We don't want to change. This is the first thing you want to know, right? Logic, flow, acceptability, this one. This is the most important, whether they understood. And that is why you have this cognitive interview. This is the most important one. This one you have to sit with the respondent and go through the question by question. 1 to 1.
How many?
3 to 5, no? 3 to 5.
3 to 5.
I use 3 to 5. Here they're saying 5 to 15. You don't have to be so many. This is where you actually ask them whether they understand the question or not, or they are rewording the question. Sometimes you ask a different question, they don't understand. They reword the question. That is what you don't want to do. This one will catch. This one.
So it can be under the pre-testing.
These are all pre-test. Your pilot test is also pre-test.
Yeah.
Anything you do before your final data collection is called pre. Okay? One of them is pilot test. Okay. You do expert evaluation, right? Most of the time you do expert evaluation with academics, right? Also no good. You have 2 types of experts. One is the methodology expert, the other one is the content expert. If you are in marketing, the content expert looking at the item, not at the scaling. Scaling is a methodology expert. Right? One each. Yeah? And then the one many people do is this one, pilot test, right? Okay. This one we are also suggesting you should have a bigger number. Small number no good, no? Because small number sometimes reliable, sometimes not reliable. I already mentioned yesterday, when you run G power, right? You write happily chapter number 3, right? What is the minimum number? Let's say you have 3 variables, 85, right? You write in chapter 3, minimum number needed for my model is 85. Huh? When you run pilot test, you have how many? 30, right? Okay. But your minimum number is 85, right? But you still happily run with 30, right? That's what is happening. You write in chapter 3, right? Minimum number to test my model is 85. You didn't change the model, right? You didn't, okay? The same model, but you're running with 30, half the number, right? How do you know it's reliable? Huh? The problem with Cromba Alpha is the more the item, reliability will go up. Bigger the sample size, reliability goes up. Sometimes your pilot test, when you run, you get 0.2, 0.3 reliability. You run with the final test, it is reliable. I examined the PhD thesis from University of Malaysia. Okay. This person has a reliability of 0.2 for the pilot test. Then he wrote there, since the data is small, maybe it's not reliable, I will continue, no change. I was like, are you joking? Yeah, you did the pilot test and you say not reliable, and then I ignore. I go and collect bigger sample, will become reliable. And finally it became reliable, so I cannot penalize the student. Okay? But sample size plays a role in reliability. Bigger your sample size, reliability will go up. More item, reliability will go up. Okay? So that's why you need to have a bigger sample if you have to do that. Number 7 is the new one they added. Number 7 is a problem called straight lining. Are you familiar with straight lining? They don't read. They just tick 7, 7, 7, 7, 7 from item 1 to the last item. So if you do data collection online, you can check how long they take to answer the question. I have a PhD student from China who use the platform. This respondent 1 minute already finished all the questions. 1 minute. The question should take about 15 minutes, right? 1 minute already finished. They are actually ticking. Those are things you can do with straight lining. Same number. Okay? So this one you have to do with the data preparation. Okay?
So it's definitely the science is not there. So we can just justify that we only want to put the cognitive interview, we don't want to proceed with it.
Exactly. All my students don't do pilot test. All my students don't do pilot test. I don't believe in pilot test. Cognitive interview is the most important one. Let's say you want to study CEO. You want to do pilot test with 85 CEO? God bless you.
How about the content validity ratio?
Okay, why are you doing that? Most of the time, your instruments are already tested many times, right? Okay. Those kind of analysis is taught in classes. If you are developing your own skill, you want to see whether the skill works or not. Some extra validation. But most of the time, the instrument already tested before. We don't have to do all those, but you need to do this cognitive interview because you want to see the comprehension.
5 to 10.
3 to 5. Huh? I do 3 to 5. Yeah.
Able to decide for this.
There's a paper, but there's 2 papers you can look at. One is called Rowley, Rowley. Right now, for you, you have this problem now. Okay. These 2 papers are good in terms of questionnaire design. Hardy and Ford, and also Chris Rowley.
Which one? You mentioned 3 to 5.
That one you have to check lah. I cannot remember.
We have 6.
I'm giving you the names already. Alhamdulillah. Huh? There are many other papers for personal design. There's another paper by Eucler and Lang. How many items to use? They also have in the folder. Like the scale, you want to use 5 point, 6 point, 7 point. Also, there are some articles in the folder. Just check, like the scale, they will show you the papers. Okay, so these are some of the papers you can refer to for the guideline. But this one also tells you 5 to 15. Here they give you 5 to 15. Size 15. So you can also do that. I'll show you how to search. You cannot see tonight, right? Okay, in the materials I gave you, if you go to the folder for reference articles, this is the folder you need to do some homework for the next 1 month. Okay, just I showed you green, right? Okay, you just type in green. Ini pandai kan? Terus pandai juga. You type in the name here, right? And they will list you all the green, right? And this is the one I was telling grade 2016, right? This is a very good paper for methodological guidance. Okay. And then we have another paper by Hula, right? This one is 2018. This 2018 one, that's a very good paper. This is Chris Raul. That's the name. Okay. And this is also a very good paper for scale 4 point, 5 point, 6 point, 7 point. Right? Which one looks better? They have a guideline. Another one is Eucler and Lang. Whether your scaling will influence your result. These are papers you can refer to. Okay, so that's for the assessment. So now we will move on to the reporting.
The model fit and model correctness of the review.
No, model fit we don't use that. Model fit is usually for CB7. Okay. We take a 10-minute break. Model fit is not required. This one is usually done for CB7. They have very limited function here. Model fit. This model selection criteria also we don't use it. If you still want to do model selection, we have an Excel template that you can use to compare model 1 and model 2.
No.
Yeah.
The system is it allow us to check economically or the system today allow us to see the economy.
They don't have one. Because the software follows the book by hand. Whatever you write there is the kind of value they use.
Can you show me the different option for macro variable? I know you showed yesterday at the piece of operation. In addition to
No, master variable and full polynomial. Full polynomial. That's why I show you how to do it. Yeah. Now this one. Okay. Hence lots of paper which are guidelines. Yeah? So they give you all the color value. Here's a table, very nice table. The color value. Yeah,
All are inside the problem.
yeah.
Or the nutrition inside the problem.
Okay, like this paper, they give you all the guidelines, for each of these question, higher order or whatever. Becker, 2023. They give you the time, okay. Becker, 2023. Yeah, it was very neat. I have a problem. This is the way it's not. I didn't find that solution. One is, my sample is very little. And even by doing the it doesn't get you. And then it's what we do. And there is kind of people. Theory percent but nothing to do this more than this. You can do this. So actually nothing to do with this. Problem is egoistic. Like, maybe 7 days or years of the time. I was given this already that you depend on the contracts.
No, but can we say that?
See this first, everybody says, yeah, everybody also the two threshold value, but actual fact, people are this one is supposed to be this one is everybody yeah.
That's what they're talking for understand.
It's a country or history.
Yeah, it's a tender number. So the whole you everything like a tax. No, scale all because he has very lenient criteria. So everybody likes that. But all this some of the things he never scales on the same thing.
The same.
No, if you want to do like I already showed that when you do expert analysis also, everybody do like addition, yeah.
Yeah.
No, it's a natural expert. You must have one methodology. That's a requirement. Other sense is if you want to you must have a number. Okay, it's follow it. And for the time, the other sense, only one
Yeah.
Whether they understand or not, also you do that.
Just like also be let's say, so let's say students really can experience change but it's
Language gap. Because I had a science student. There was some I had to do negative version. I people don't have negative version. You translate negative version from English to Thai, like three sentences that we so you don't have actually the answer. Another topic, there's probably, not paper. There's no, my email, depending on your place of data.
Some examples
But
That's what people want. Three of them. So we found
So for me, if you follow, need to yeah.
the folder that you can send. Or
For this time, you can follow. So
the also for statistical power.
Yeah.
Also, it's for effect size.
If I say excess.
Article analysis, now you start how you have to clarify this. Article is you have to compare male and female. The same model, same for male or female. That's how it's. Then how do you classify your personnel?
So she wants.
Classify the manager.
She's like.
Also, I think five previously we do classify. It's not as a from small line dimension. Some 25, some 28. You all know also know. In the when you have a continuous you need to classify. Yes. So what did it say?
My central one, it's like yes, but you there is something like that. You need to carry it off. I've seen one and it's not sure. So maybe next one, I was trying to tell. I see the
Can be independent. You look for a box for all the labor you put seven.
Because in Google Class,
All. That's how I go. They are running the same model for one group compared with one thing other than relationship.
Yeah, that's
Later and you get.
yes.
You can write I understand it's actually moderation.
So that you just say that you best. Well, I guess small institutions. It's all really
For moderation, for aligning all relationship with people and multiple. If you put only one relationship, it's a non-relationship.
It's very cute. It's not right. You look at that. It's a conscious strategy. Yeah, that's what she thinks. Exactly.
That's why it's always happening. That's why they didn't say that something is wrong. Huh?
I don't know, but she's sister. Yes, you can.
There have been like running the model, sales, is not the model, the vessel. But you know, it's true. Oh, this is like, if you look at that, you're comparing differences. How do you other facts, uses the sun. Minimum of must be learning for both groups. That's
It's really yeah.
amplify which is probably there's one real probability from the anchor. Can be done here.
So,
And if we can,
she's so much reading. Now I know what I can do.
no, just not good.
Yes, yes, yeah. Okay.
Oh, it's fine.
That's how it is. So can I use my the vision that I had? Right, so I did extra version. That's we can do. I have. Okay, so it's my weakness, and I can expand my vision and had. Because we are seven, just from the ingredients, then the ideas. So
Okay, so everybody back, huh? Okay, now we will move through how to respond. Huh? So we will follow this 5-step process. Huh? We will do the normality test. Huh? First, we will do this test called normality test. We have two types of normality, univariate and multivariate. Okay, the software called SmartPLS cannot test multivariate. We need to use a website. Okay, we need to use a website. So we have two univariate and multivariate. These are the kind of value, plus minus 1, plus minus 7, and plus minus 3, and plus minus 20. The difference between univariate and multivariate is univariate, you are looking at one variable at a time. One variable at a time. But multivariate is you are looking at multiple variables at the same time. See here, x1, x2, independent variable 1, independent variable 2, are they together forming a normal distribution? That's why we call them multivariate. This is univariate, one at a time. Okay? This one is not a requirement in multiple regression. The requirement is this one. Okay? So in your software that you have, can you go to latent variables? Can you see this latent variables? Okay, these latent variables, they are already standardized. The item value minus the mean divided by standard deviation. That's why we have a minus and positive. Okay, so if the item value is lower than the mean, it will be negative. If the item value is higher than the mean, it will be positive. That's why we have a plus and minus. Okay, so this is what we also do in FPTS. Remember, you compute, transform, compute. For each respondent, you have a score, right? This is the score. We have two types of score. One is the standardized score, which is mean 0, standard deviation 1. The other one is unstandardized. Unstandardized means it will be within your scale. 1 to 7 means your mean value will be 1 to 7. Okay, so that's called unstandardized. We can get both. So we will copy this first, copy to Excel. After you click copy to Excel, you need to open an Excel file and paste. Okay. Excel file you will paste in the first tab. Right click and paste. Okay. Okay. So you finish copy paste. Yeah. The numbers start from a 0, right? Okay, that's why if your sample size is 191, it will end in 190 because number 1 is 0. Respondent number 1 is 0. So we have already 191 cases. This first column is ID, right? So you just type in ID here.
Sorry, I'm sure.
It will be okay. After you put in the name ID, you need to save this file somewhere you remember lah. Later we need to upload. So what you do, the easiest is to save this file on the desktop. I usually use a name called later. Okay. The file name can be any name, okay? But I prefer this, latent variable, right? Okay. Save it on the desktop, because later we need to upload, then you cannot find. Easier to be on the desktop, okay? Just file save as. File save as, go to your desktop and save it. Okay, once you save, you will see the name is already on the top. Can you see here, latent? Okay, this is the file we need to upload to the website. And before we upload to the website, you need to know the column number. Okay. Your data is in what column numbers? We have column 1, column 2, column 3, column 4, column 5, right? Your data is in what column number? This is column 1. This is column 2. This is column 3. Okay, now understand? Okay, you have 5 columns, right? Your data is in which column? Okay, column 2 to 5. 2, 2. This is not column number 2, column 3, 4, 5, right? This is column number 1.
1.
Okay, so you are not using column 1 because it's ID, not your data. Data starts from column number 2. Why I explain this is PhD students are not very clever. Not very clever. If I say stupid, they become very upset, right? So I'm saying not very clever. When I do my data, I tell them 2 to 5, right? They go back, their data also, they put 2 to 5. Their data is longer. So you need to know the counting the column. That's why the column number. So if your data is until here, you have 6, 7, 8, 9, right? You have to put 2 to 9. If the column number is not in sequence, you want to read column number 2, 4, 6, right? 2, 4, 6, That means they will read only 2, 4, and 6. That's how the software understands. Okay, so we already said this. You must close the file, because or else you will not be able to read. So now we go to the browser. Go to Google. In Google, you just type this web power. You will see this, right? Web power multivariate factors. This is a calculator developed by the authors called Kane et al. They saw that many people who do regression, they don't report multivariate normality, which is the first assumption. Okay, so that's why they developed this website for you. So if you click this, multivariate synthesis. Okay. So they will take you to the top page. This is the page you are looking for. Can you see the web power? Univariate, multivariate, right? Later you can do the bookmark. Bookmark, okay? So this is the calculator. They have now developed another new one. This one, but we can use this one. So here, this is the calculator. First, we have to upload the file. That's not the file you saved. Upload here. Okay. The file you saved just now. Later, remember? So use file and go to your desktop. We have the data, right? Okay. After we upload the file, here you have to click down. Your data file is Excel, right? The Excel, right? Okay, here is SAV, cannot click down, change it to Excel.
Okay, register first, right?
No need.
So, is
Just click down here, we change it to Excel. Yes, this is where they ask you the column number you want to read from. You see? It's amount, we need to save the scores. We can get same thing. So SPSS also can do, SmartPLS can do, EMOS also can do. You only need the scores. Okay. So this is the thing. So when you want to report, this is your result, right? You can use your snipping tool, right? We need to snip this, copy lah, copy this and paste in your Excel. Okay. So what I normally do with my student is I will create an Excel file. And in the first sheet, we will put here multivariate normality. Yeah. So all the analysis we will do, we will save them one step at a time. So later we can come back to the Excel file. So now we are doing multivariate normality. Yeah. So what you do is you copy the drawing just now we got output, paste it here first. Later you need to write, no? Because let me check number 4. You forget what is the number, so we can copy and paste or write down somewhere. Okay. This screen, right? So you press the print screen. I have a snipping tool, so I can snip it like this. And I paste it in my Excel. Did you get it? Or you just print screen and paste. You get this, right? Okay? Print screen. Print screen, right? So this is the table we need to report. The number we are interested in is the last two at the bottom. Can you see these two numbers? These two numbers are the one we need to report. So that's why I keep this here. So if you want to see how we can write in our report, so you can go to the folder called slides. Can you go to the folder called slides? Folder called slides. Number 4, that's a sample write-up. That's a sample write-up, right? Okay. This one. Okay. When I went to Pakistan in 2020, everywhere I go, they say, can you give us a template? So I included this template because of that. Okay. So you can scroll down. You can see at the bottom here at the section called structural models. And you already have the citation. Can you see the citation? And this is the citation I'm using. Okay. The calculator, remember the calculator? There's a sentence they ask you to cite. Since I use this, right? I use this. Okay. And the number is from the output just now. We have these two numbers. This number and this number. It's not the snapshot, right? We have two numbers. As long as they are more than 3 and more than 20, they are not multivariate normal. We need to run bootstrapping. Why 10,000? Because Becker's suggestion. Okay. So that's how we write up this section. The step is to decide whether we need to run bootstrapping or not. Number 1. Any question on this? It doesn't matter what software, we are actually supposed to do this. In multiple regression, the first assumption is data must be multivariate normal. Right?
So question is that after you have run the bootstrapping, you still require to rerun coding again?
No. This one will correct the standard error in the structural model. The rest all doesn't change.
So after that, you continue.
Yeah. This one is to decide whether you will run bootstrapping or not. That's the only reason we are running.
How many people are assumption in PLS?
Itu ajaran sesat. Hare actually wrote this in 2014. He said you need to report a multivariate normality, but he has no solution at that. Hare is not a statistician, by the way. Hare is a marketing researcher. Oh my God. Insider information. He's not a statistician. That's why Hensler didn't like him. Hensler is a statistician. I see some of the things mentioned by Hare is not. He doesn't agree. That's why they actually separated. One of the reasons Hensler left the group was because he didn't like Hare. Said Hare is not a statistician. So some of the things, the guideline he gives is from marketing perspective, not from statistical perspective. And so that's why this you need to understand why we are doing it. So this step was developed in 2017 by the authors. So that's why they give you this. Previously they didn't do this. If you go back here, right? Can you see here? When you use the calculator, previously they didn't have the disclaimer, but now they added because many people use, they are not citing that. which is unfair. They already give you a free calculator, you're not citing them, right? This one, can you see? How to cite, because you're not very clever at citing, right? So then you can copy and paste from here. Okay? So if you use this calculator, you have to cite in your reference. I use this calculator from where? Okay? Okay? Done? The article is this one, it's already in the folder. Okay.
I just want to clarify, if you may go back to the risk calculation. So you're actually looking at the whole row. Yeah, so you're actually looking at the second row. Okay, not the one.
This one univariate.
Okay. So
This is univariate, but univariate is only for t-test one day ANOVA, remember? If your dependent variable not normal, instead of t-test, you use memory. Okay? Instead of one day ANOVA, we do Kruskal-Wallis. That is for univariate. But we are now doing multiple regression, right? Our concern is this two. This one, the software don't have. That's why we are using the website. Okay, so that's number one. So number two, I want to show you. First is the full polylarity. Do you have SPSS in your laptop? Then we have SmartPLS. How many of you don't have SPSS? Okay, so first, the data we already have, right? Just now the Excel file, can you open the Excel file just now later? Okay, this is the data file just now we saved, remember, Leighton? In your desktop, okay, you forgotten earlier. I asked you to save on the desktop, remember? We will open the file, we have the same variable, right? And the last column here, you will type as marker. No, random, sorry, random. Type in random, Okay, R-A-N-D-O-M, Okay, now we are going to create a random variable. So what we will do is all these variables, we will regress against this random variable. Okay, so in Excel, the random variables are created like this. You start with the equal sign. And then R-A-N-D, open bracket, close bracket. You can create random variable in SPSS also, but the formula is different. In Excel, R-A-N-D, open bracket, close bracket, they will create a random number variable. Okay. When you click the enter, they will give you the first number. Okay. The number you get will be different from mine. Kalau sama tak random dah. The name is already random, right? So the number will be random, randomly generated. Each of us will have different number. We need to copy it down. Okay. How do you copy it down?
Okay, please.
No more dragging. Dragging is 10 tahun dulu lah. You're still 10 years behind. Okay, when you get a plus sign, you double click on it. When you get a plus sign, right? Just double click. They will copy the formula down. No need to sorong papan tarik papan.
Basically, apa?
Abang you tarik, setengah jam tarik tolak papan. Jadi sekali dia kan, dia dah copy semua kan, tenang. This is something I learned during the workshop also. They said, oh, no need. So this is the variable we created, right? Okay, now we save this file. Okay, after we save this file, we can do two things. One, we can do with SPSS. How many of you don't have SPSS? Yeah?
Yes.
We need to run regression. You have any software in your desktop that can run regression? JAS, Jamovi, whatever can. Ada? Ada. Tapi kena ada data file dia, kena save data file pula. If you have to use your desktop, you need to save in a pen drive, okay? Don't have, then okay. And those who don't have, okay, you can save it to a pen drive and then load in the desktop. Okay. Okay. Okay, you need to open your extended first. Okay. So first we will open our SPSS data. You need a pen drive?
No, I'm gonna send YouTube. Thank you.
Okay, first you open your SPSS, huh? You have you created a random variable. Okay, save the loop. To the SPSS to read the file in the SPSS. Okay, from SPSS, you now need to read the file Excel in the SPSS.
How about this though? Actually, operate as a binding.
No, you can, but Excel, that's Excel.
Okay.
Now we have to read into SPSS, huh? So that you have the same variable in SPSS, huh? Okay, SPSS will look like this, right? So you go to File, Open Data, right? And File, Open Data. We will go to the desktop, right? Okay, but in the desktop you will not find the file because it is SAV. Change it to Excel, huh? And then at the end you will see your latent, right? Or else it's looking for SAV file, right? Don't have, huh? You need a file, huh? Just click open the list.
From import to can, right?
Can. Import data also can. For data also can, huh? So once you read this file into SPSS, then only we can run regression. This one only okay. So once you open this file, right, they will read into SPSS, huh? So it will look like this, huh? The only file you have is latest, right? This is the file, right? Can you see the file? Okay. The file variables you already have, huh? Okay, done. Okay. Now we want to run a regression. Huh? When you run regression, you need one dependent variable and multiple independent. Huh? You go to analyze. Okay, go to analyze. Okay, and then regression, linear regression. Huh? Analyze regression, linear regression. Okay. After you click this regression, they will ask you what is your dependent and independent. Huh? Okay. Your dependent is random. Your independent is all other variables. Can you select first? Huh? Okay. Now listen first. Huh? When you do your own model, don't look like this. Huh? It will look more variables, right? You have moderator, you have mediator, right? You have to select all the variables. Okay, this is different from what you get in SmartPLS. SmartPLS later, we will also have VIF. Okay, the VIF in SmartPLS, we have for independent only. They don't give you for dependent. Okay, independent only. Yeah? So this is how it works. Huh? Okay, in your, when you learn in your regression, right? You have independent variable 1, independent variable 2, independent variable 3, and then 1, yeah? Okay? When you run multicollinearity, just checking whether x1, x2, x3 is highly correlated or not. Right? Multicollinearity, whether the independent variables are highly correlated. Okay? So independent variables and dependent variable highly correlated. Okay. Independent cannot be highly correlated, right? Independent and dependent highly correlated, okay or not okay? Okay, your SPSS instructor tells you very good, no good, no good. Okay. You understand, right? After this one is 0.9. Huh? Tadi satu variable sudah lah. Awak pergi cari 10-15 variable buat apa? One variable already R square. Okay? The other variable will not be significant. No? So this variable is already explaining everything. Cannot, no? Cannot, no? IB and IB cannot be highly correlated. IB to DB also cannot be highly correlated. So that is where the concept comes in. Huh? Okay, when you do this, this is called vertical collinearity. Yeah? This is what we call as lateral. Okay? So now what we are doing is called full collinearity. This and also this. Okay? That's why the term is full collinearity. What you get in your SmartPLS is only vertical. IB to DB only. IB to DB only. Yeah? Okay? So when we run this, we have to click the statistic, right? Can you do the statistics? Okay, this is the button we need, called collinearity. If you don't click this, they will not give you VIF in SPSS. Okay, so once we run this, they will give you VIF for all the variables, independent, dependent, moderate, intermediate. Okay, and the value should not exceed 5. If you exceed 5, you have a problem. Okay, so that's the criteria. Okay, let's click continue. And okay, yeah. What will happen is they give you a long list of output. The table we need is this table. This table, right? Okay. So click on this table. Right click and copy. Copy this table. Right click, copy.
Can you go back to the screen what we have? Linear regressions and regression.
Okay. First, analyze regression, linear regression, right? Independent, okay? Statistics. We click this one.
Questions.
If you want to identify outliers, you need this button. But we are not doing this in SPSS, right? If you want to know outlier, you need to click it. They will give you the case-wise outlier. This is the one we need. Okay, so after we click this video and OK, what will happen is they give you a long list output. This is the table we need. Can you right click on this table, coefficient, copy first. Right click, copy. Okay. Once you right click, copy, when you go to your Excel, in your Excel, we are already now doing full collinearity, right? Okay. When you right click to paste, don't click number 1, click number 2. Okay, number 1 is ugly, right? Number 2 nice, edit. So click number 2. Number 2. Okay. So now we have a table, right? You have a table? Okay. We want only this column, and this column. The rest of the row and column you delete. This column, the name of the variable. Okay. and the VIF. That's the only two columns in it. The rest of the column and the row you did it. Okay. So I highlight and show you which one you need to retain. These are the only two columns needed. The rest all you did it. Until you have only two columns. Okay, I will wait for you. Delete it. Tahu delete kan? Dekat atas. You highlight this. C, D, E, F, G. Highlight and then right click delete. It will reduce. Like this. You highlight C, D, E, F, and G, and also H, right? Right click and delete, they will reduce, right? Okay. These two rows are not needed, right? They are not part of our model. And this dependent variable also not needed. And A also not needed. So you are left with two only, right? Okay, so you have only two columns. Okay, the row called constant is empty, right? We will delete that as well. Then left with a name called variable. Okay, so if you have to present them like this, also you can. But in papers, they don't present like this. They will convert them into rows. You know how to do that, right? Okay, so kita belajar Excel lagi. Okay, like this. Highlight first. Highlight the two columns. Done. Okay, and then you right click and copy. Okay, right click, copy. Done. Okay, now you go to the column number C. Right click. When you want to paste, there are some option, right? We pick the transpose. We're changing column to row. Okay, that's what we are doing. Okay. Column to row. So now I have a table, right? Okay. So you want to present like this also can. You want to present like this also can. Now most of the papers present like this. Okay, so you can do whichever one. Okay. After we have this table, you want to look at the number, right? VIF must be less than 5. If the VIF is less than 5, then you conclude you don't have a bias. Okay? Less than 5. This is for those who don't have marker variable. You already collected data, right? You cannot go back and collect the marker variable. This is the only method you can do. Okay? This is the only method you can do. Any question? Okay. For this step is needed for all who collect data using a single questionnaire. And welcome to Malaysia. Everybody is using single source, right?
Hello?
Yeah, somebody's asking.
So this is the
நீங்க வந்து item தான்
one
சொல்லணும்.
of the requirement for the regression, right? So the
No. This one not the regression requirement. This one is requirement because you have single source data. Multiple source, don't need to worry about it. But most of you are not doing that. Most of you are doing one questionnaire, everything. Good journalists don't want to even look at your data because we don't know whether there is a bias or not. That is why we need to show this. At least we are showing this. But this is not a very good method. Okay? This is not a very good method. This is for those, in Malay we call it terlajak perahu. Tak boleh go start, boleh go ahead. Then you have no choice. We need to do this. Okay? We need to do it.
If not to find the meaning of data.
You have two variables highly correlated.
Okay, step 1.
Okay? More than 5, right? That means two of the variables are highly correlated. Your result cannot be interpreted because you have a problem called multi-coding error. Okay. So this is two polynomial. And now I'll show you another option, it's the marker. This one,
Yeah.
This one is for those who didn't collect the marker variable. If you have a marker variable, this is not needed. The second one, so I'm going to show you the next one. Okay, so now we want to do the next step for the marker variable testing. For marker variable, we will have two models. One is your baseline model. Baseline model is your own model. Okay, your own model, independent, dependent model, immediating control variable, all put in it. Then the marker variable model is you add the marker variable into the model. So we have two models, marker baseline model and method factor model. So I will do the label first, before we start doing. So I write the variables. The first model is baseline model. Then I change the font bigger again, so that you can see. Just type in the label first, then I show you how to do comparison. We need to compare two models.
Baseline model, marker without marker, is it?
This is your own model.
Model.
Okay. This is the model plus the marker variable. That's why it's called method factor model. Just type in it. And now we are at the third type, right? Marker. We already done multivariate. We have done full polynomial. We are doing marker, right? The third one. So we have two models. Baseline model is the model without the marker variable. Your own model. Okay, your own model. The second one is we will add the marker variable to the model, and then we do comparison. Okay, we will do comparison. Okay, so now your model is already here, right? Can you see this model? This is your full model, right? Okay. So what we need to do is we need to run bootstrapping. We need the data value, we need the p value, we also need the r square to do comparison. So rerun the model, go to calculate bootstrapping. Update bootstrapping. After you click the bootstrapping, change this to 10,000. This one we have to change from important faster to slower because we want more output, right? Just click it down, change it. Complete slower. Okay. And this one we change it to one tail. Okay, why one tail? Because your hypothesis is positive relationship and negative relationship. One tail. Okay. Two tail means there is a significant relationship. Okay. Yang tu pun
Oh, in our report, also we run so all this we need to write it everything is.
No. When you run your analysis, the process you explain in chapter 3.
Yeah, okay.
Chapter 4, you have to report the final one. Okay. Whatever item you delete, you have to write in the text. I remove some cases because of outlier or whatever you do, that you have to write in the text. But your final table is the output you want to interpret. Final table. Okay. This is the setting.
Sorry.
Yesterday I told you, right? If you run with 5,000, the normality is not nice. 10,000 very nice. If you don't the distribution. Okay, so now if we run the result, just click the start calculation. They will run and give you the p values only, but you have to click here, structural model to change it, right? Okay, currently they show you all the p values, right? But I want to show the p here, click here. We want the path coefficient and p values so that we see them side by side. Path coefficient and p value. Change it to this one. Okay. Once you change it to this one, the path coefficient will be outside. The p value will be in the bracket. So we have both side by side. Okay, like this, right? So this is the number and this is your R square. We need this and this. Okay? This and this. Okay. So if you look at the p value, this is significant. This is significant, right?
Yes.
This is significant.
Yes.
This is significant. All three significant. Now this is what we call as the baseline model, your own model. So we will copy this and paste it in your Excel. Okay. Just click here. Right click. Okay. Export as image. Just click export. And we will paste it here.
The PNG form.
No, any form you can, as long as the picture is a picture file, so that we can compare them side by side. So these are the numbers you can see clearly, right? Okay. This is your own model. Okay, copy and paste first. Okay, after that, then only we will add in the marker variable. What we want to see is whether the beta value now significant, right? If it becomes not significant, you have a problem, right? Significant become not significant, you have a problem. Significant remain significant, no problem. R square now 56%, suddenly R square going to 70%. That's a problem, right? So R square increased too much. This marker variable becomes an independent variable. So they are actually biased. Okay? They are biased. So that's what we are doing. Okay, so after we have done this, what we need to do is in my data, I have collected this M1, M2, and M3. And you see the bottom here? These are the three items I collected as a marker variable. Okay, again, no need to memorize the number. The marker variable can be 2 items, 3 items, 4 items, 5 items, 6 items, 7 items. That depends on the variable you adopt. From where? Okay, I showed you some example, right? We have 2 items, 3 items, 4 items, 7 items also got. Which one you want to use in your study? You need to decide, okay? According to your area. If you're in marketing, look for marker variable used in marketing. Okay, this is a question I always get. No? I've never seen this in my literature. First time in your life you will see this today. There are many articles. The problem is you're not finding the right article. In psychology, it has been a standard for a long time. We have a variable called social desirability. Social desirability, that is used as a marker variable. Another variable is called PANAS, positive effect and negative effect scale in psychology. But problem with social desirability is the items are quite sensitive. I like to gossip at times. Your questions are all system. Suddenly, you like, I like to gossip at times. The whole question they cancel. They say not relevant. The respondent will cancel. So they say this is not related to system. That is why we need to look for items which are in your area. Okay. So most of my students use a variable called cognitive rigidity. So if not, you can use the preference for color blue. Yesterday I showed you, right? They have different versions, 4 items, 7 items, and so on. Which one you want to use is up to you. But you must have them in your questionnaire. Okay? This one I already collected in my questionnaire. That's why I can do this. If not, cannot do this. That's why I showed you the earlier one. The full collinearity is for those who didn't collect the marker value. Okay, so now I have the marker value. So we will drag and drop. Just drag and drop here, and then I will label it as marker. So I already have the variable. Okay. Now you have to listen a bit. I have this marker variable, right? Let's say you have a mediator and a dependent variable. You must point at the mediator. You must also point at the dependent variable. All the endogenous variable. Endogenous means that has R squared. Independent variable is exogenous. So no need to point at that. So we will point this here. This exercise I have only one, right? So I point it here. Now the R square will change, the beta value will change. We want to compare both models. Just point this arrow to this variable. So now we get a new result. We will copy this and paste side by side to do comparison. Okay, that's the process. Okay.
How to enter the rank, the mark?
Just drag and drop. Three items at the bottom, M1, M2. Just now we drag and drop, right? Okay. This is the result after, right? Just copy this and paste beside the table. Right click. Expand image. And now you have the model side by side, right? M1, M2, M3. Okay. Select. Oh, that one's not. Yes, sir. That's it. Let me click there. Okay, we already have the result, right? Okay, first we want to look at the R square change. R square didn't change, right? That already tells you you don't have a value. You don't have a value. Okay, you look at the beta value here. Is significant? Still significant? No change. Okay. Significant. Beta value drop, right? But still significant. Okay. Here significant. Here also significant. Yeah. So the result didn't change at all. So we can already conclude we don't have a single source bias. You need to show this first before I can look at your result. If not, I don't know. So that's why we are doing this method. Okay.
Yes, any differences?
Okay. Here significant. Okay. Here not significant, right? There is a bias, right? Okay. You don't report this. You have to report this model. Because now it's already controlling for the bias. Your result is after controlling for bias. So both can be reported. Okay, just now when we did the full collinearity, right? Let's say your VIM is more than 5, you have no remedy. You need to delete one of the variables. You lose one hypothesis. The first method. This one we still retain all the hypotheses. We can still report. And we can say because there is a bias, we are already controlling for the bias.
So it's very relevant, no treatment.
Oh, just report. We report this fast.
Just report.
We don't take out this one, we report the result. We are now already controlling for the bias. That's what we need to do.
Prof.
Yeah.
Paper form can.
I've already given you a sample how to report table form. I'm showing you this for ease only. When you run it, right? The software will give you all the data value, P value already, right? You can put side by side to compare. R square here, we can compare. So what I've done in this paper, okay, in this paper, okay, this is the paper I actually wrote in 2024. Every time I do show this, right? I'm already showing you step by step. No? Please, still people cannot understand. No? So that's why I wrote this paper to show how to report table step by step. Okay. So if you open this paper, in this paper, what we did was this is the model, right? Can you see here? We have two mediator independent. Your marker variable will be pointed here and here. So we need to have two R square, right? This is the first one, and then with the marker variable. So you see the table. This is the table that I want. Baseline and marker variable. No other paper in the list of articles I've given will show you like this. Okay, because this is easier to interpret.
If you don't have, so that once we delete one, item, then we lost one of our application.
No, you did no items, delete variable.
Variables.
Okay, remember we have 5 variables. If the VI have more than 5, these 2 variables highly correlated. You need to delete one, no? To lose 1 variable. 1 variable means 1 hypothesis. Okay, that's serious. That's very serious. So that's why this method is a better one. Even bias also we can still report. Not bias also we can report.
But in this case, there's no biasness, is it?
No.
Is there any biases?
No.
Is there any?
Upper didn't change, right? Okay, and the beta value still remains significant with and without. So there is no bias. If the result changes, then only there is a bias. No, if you have a bias, you report the model with the marker variable in the model. You're already controlling for bias. So the editor cannot reject your paper because your data is biased, because you are saying my result is already controlling for the bias. Okay? Control variable is pointed at the defender variable, remember? Right? We are already now controlling for the bias. And that's why we need to show them like this. Okay. This one is a Q1 journal in Scopus, but you have to pay about 1,600 euros. Or else you look for a portal from MMD. You will pay the fee in full. Okay. That for the market. Right? Okay, so we have already done these 2 things. We have done normality. Which normality is to run bootstrapping. Okay. Then we have these 2, right? So don't have to do both. Don't have to do both. The third one is better, but for those who already collected data without marker variable, you have no choice, right? You only report this. Okay? Those who have marker variable no need to do this. Just do it. Okay? That is a choice. Okay. Okay. Now we want to report our results. So for results, we will start with the measurement model. So I'll show you how to do the table. So for measurement model, in structural equation modeling papers, the first table you will see is called the measurement model, correct? They have the variable name, they have the item, loading, ADECR, right? That is the table every paper will have. Doesn't matter MOS, PLS, M+. That is the table we are going to develop next. Okay? So how do you get that table is, first, you go back to your result. If you go back to your result, this is your bootstrapping, so we don't need it. Can you run the algorithm? Algorithm. Before we run the algorithm, not to run, we remove this first. Because there is no bias, right? We can remove this. Remove the marker variable. Click the select first, and then remove the marker variable. Rerun the algorithm, and you get back the same results, which are the loadings.
Just now the paper evaluation. Just now you only run machine evaluation.
So we ran bootstrapping. So now we already got the value.
No. No, it's difficult.
We ran this already. I ran bootstrapping because of report. Okay, so now we get the result. Can you open the full report? Open the full report and go to outer loadings. Outer loadings. Okay, you get a table, right? outer loadings, huh? So, okay, what we want to do is we want to copy this table. And you copy this table, click copy to Excel, this table, huh? And after you click copy to Excel, in your Excel file, you will paste it on the second column, huh? Not the first column. Second column, huh?
Yes, right. After open up. All strategy. No, not basic. It's a basic. Or, and there's a particular basic. Yeah, how they get it.
Okay, second column, second column, equals open full report. Full report. For outer loops. Okay. Click the outer copy first. Okay, and then go to your Excel. Okay, I think many of you need Excel training also lah. Okay, so again.
Another extra training.
No, because when you want to report, this helps you lah. Okay, just now we copied this file, right? Okay, undo the file first. And now you have your output, right? Okay. Outer loading is here, right? Can you see the outer loading? Yeah. This is the table I want to copy, yeah? Okay. When we click this copy to Excel, they copy to a temporary folder. Okay. When you come to your Microsoft Excel, okay, when you want to paste, before you paste, listen carefully, yeah? When you right click, don't pick this one, pick this one. The second one. Okay. You have a very nice table, right? Easy to edit. No boxes. Okay. Edit. So now I can make it bigger, right? Okay. Easier to report. So this is the table we want to do editing. Yes. Everybody okay?
Yeah.
Okay. These are all loadings, remember? Okay. So at the top there, we need to do the labeling first before we develop the table. Okay, the first column will be your variable. Second column will be items. Third column will be loadings. The fourth column is CR and AAV. These are the labels. So these are all loadings, right? All of them are loading. So we need to drag this and drop it. All go to the same column. All go to the same column. You want to cut and paste, copy and paste also up to you lah. But you can actually drag and drop. Okay. Okay, like this, huh? We highlight the table, but like this, we just drag and drop it here. Just highlight here, drag and drop it here. Highlight, drag and drop it here. Then I want to do center. Okay, so you have a nice table, right? On the left, this and this in the center. You have to center them, so that everything is nicely displayed. Okay, this decimal place should be 3. Okay, here we have a increase or decrease decimal. So that is considered. Okay, so wherever name you can type in on your phone. If you forgot later, you can copy and paste. So your wherever name already later, you can copy and paste. Okay, we need these two values, CR and ABE, right, to complete the table. Okay, CR and ABE is already given in the output, right? So here, you go back to your output, and in the output, now you go to a bit lower. You see this construct reliability and validity. Construct reliability and validity. We click this table. We need the third and the fourth column. Okay? These two columns are not needed, but we cannot copy the column now. Just copy this table, paste it beside the table, so that we can copy and paste. Okay, we copy this and then we paste it beside the table like this. Then these two columns are not needed. If you want to report all 4, it's up to you. But usually in many papers, they only report these 2 numbers. This is your composite reliability row C. This is your ADE. That's right? Now we need to copy this. First, we do this. Complexity, right? This is the variable here. You copy and paste it here, or you can type in on your own, since you are very fast typing, right? Just type in easier, or you copy this and paste it here. Name of the variable, so that you remember. Okay, this variable is complexity. We copy and paste it here. Enjoyment, we copy and paste it here. Satisfaction, we copy and paste it here. And finally, we have usefulness. So that is for labeling.
This one is
Okay, now we can copy these 2 numbers here. Copy and paste. Transferring to the function. These 2 copy we paste it here. Okay, so each of these 1 pair copy according to your variable. Okay, 1 variable only 1 ABE, 1 CR, but the loadings can be many. Okay, loadings can be many. So this is how you complete the table. Once you complete the left hand side, the right hand side not needed anymore. The right hand side is to complete the table only. So we will throw away the right hand side. Your table is ready. Okay, that's how you develop your measurement model for reporting. Okay, so table ready. Okay, so once we have the left hand side ready, right hand side no need anymore. Okay, only to copy and paste, right? Okay. This side is actually to do the reporting. So we will need this. Okay, this part here we don't need. Okay, this is the table we need. So in your Microsoft Word, so now I show you how to report the tables. So that we have them ready, Okay, we will start with table number 1. Measurement model. Highlight this, change the spacing. I want to change the spacing to single space. And then this will be bold. This will be this is APA 7th edition, right? Table is bold. The title is italic. So after you have done the table and the title, just now we have the table in Excel. You can copy and paste it. Copy and paste it. Bila paste nombor 2, bukan nombor 1. Nombor 2. Nombor 2 ni tempat ada line. Senang nampak. Okay, like this. In your Excel, this is the table I want to copy, right?
Yes, sir.
Okay. Highlight the table. Right click copy. When you paste, we have an option. Can you see the option? This one, they don't have the line.
Yeah.
First one. The second one has a line, easier to edit. Okay, that's why I picked the number 2. Okay. After you pick this, it's easier for you to drag the table fully justified. You see? Okay. And then these 3 columns, we will highlight and center. Okay. Then your table is ready. Yeah? And we will put a note here. There was one item we deleted, right? We deleted one item.
Yes.
Okay. So we write here. Enjoy 1. What deleted? You do. Okay. So what we are telling the readers is, we actually had one more item here. See here? This item is missing. We have already deleted that, because the loading was less than 0.5, 0.6 or 0.7. Okay? Done? Okay, now I show you how to format the table. When you report in paper, you don't report like this. We only have the top 2 lines in the bottom. Okay? So what you do is highlight the table first. Okay. Before that, you know how to do all same length. Some of your tables are like this, kan? Macam ni lah. Kita highlight di table dulu. Highlight dulu. Okay, right click. Dia ada distribute columns evenly. There are 2 will give you all the nice size. Ini yang pertama lah. Column. Okay, number 2 is this one. I want to change the lines. I don't want the lines. I only need the top 2 lines and the bottom line. So when you highlight the table, you see a table design coming up.
Yes.
At the top. Table design. Okay. So if you click the table design, they give you some options with the color coding. So many options. If you scroll down, you will find an option which is the closest match I want. It is called list table 6 column. Can you see?
Yeah.
Change. We have the line, we have the bottom line.
Yeah.
Later we can remove the shading. Okay. So this is the one I do. If you are clever, you can do the rest also. You can develop your own table. Saya tak berapa pandai, guna yang ini sajalah. This one, list table 6 colorful, right? Okay. Once we click this list table 6 colorful, there are some shade, bold and shaded, right? We don't need it. So if you click the button home, there's a button home there. Remove the bold and the shading. Then you get a nice table. Like this. Click home. We don't want the bold, right? untick the bowl, and then this is shading.
Okay.
Now I have a very nice table, right?
Yeah.
Okay? Okay. 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 So it doesn't matter paper or this is, this is the table just to put it through, okay? Okay, so we already have all the information we need, So after we have the table, we need to explain the table. Okay, so we need to answer 4 questions, And these are the 4 questions you need to explain, So these are the 4 questions you need to answer, right now, The first question is what is convergent validity? We can copy and paste, because everybody writes the same. No need citation. From Umasuk Sekaran's book also you can. Convergent validity is the extent to which items measuring the construct load highly on their particular construct. That's the term. Everybody uses the same explanation. No need citation. For the first one. The second one, you need a citation. According to Hare et al. 2022, we assess validity by looking at the loading and the AV. Okay? Validity by looking at the loading and the AVE. Yeah? The reliability, we will use composite and reliability row C, right? You can also use row A, which is more conservative. That one you can decide. Okay. Number 3 is the cutoff value. Loading must be greater than what number? CR must be greater than what number? You have option. You need to cite which author you are referring to. Okay. Number 1, you need citation. Number 3, Number 3, Number 4, you need to point to your table. Don't say see table below, see table above. And then the table 6 pages, 7 pages later. If I'm the examiner, my blood pressure already go up, and your grade already go down. And you expect me to go and find the table. Okay? Not good, no? You must number them, no? Later, when you do the appendix also, you must do appendix 1, appendix 2. So that the examiner can go directly to the appendix. Don't put all the appendix 100 pages.
The appendix for the output.
Your output goes into the appendix. Okay, but you have to separate that. Which table is in appendix 1, so that the examiner can go directly to the appendix. Appendix 1, appendix 2, appendix 3. Okay, so this is table 1, right? Then we will compare. The loadings are all more than 0.5. CR is more than 0.7. AV is more than 0.5. This is what we are comparing. The cutoff value you already write in chapter 3. Chapter 3 you already write the cutoff value. Now we are actually comparing. But if you are writing paper, you write in the same section. Thesis and papers not the same. Okay? Like paper, when I write, I don't write very long. You can see here, right? This is the table you did just now, right? You can see? Okay. Then you have the explanation. Huh? These are the maximum ones. Yeah. All the numbers are there, right? Okay. So different authors have different kind of value. Huh? So which one you want to use is up to you. Okay. So this is the first table. Okay. Any questions on the maximum one?
They're not there. We see them in it's not item for enjoyment. So we just need to present the text, the
This is the only thing, this is the only item I deleted. If you have more items, you put in a comma lah, huh? Comma 1, comma 2, comma 3, right? Each item you deleted from the. Yeah?
Most addition required.
No, you are deleting because the loadings, we have a cut off loading, remember 0.5? Anything less than 0.5, we cannot retain. That you already write in your earlier.
So the way you decide and section. If you decided then remember you
No. Usually what happens is you have items, right? Suddenly you have an item useful 1, then you have useful 2, you don't have 3. Then the review will ask, what happened to useful 2, right? But I'm writing at the bottom, right? The item 2 was deleted because of this reason. So I don't ask the question. That's the reason why we have this table. To show which items were deleted. Okay? So here we can delete up to 20% of the item. Total item. Okay? More than 20% is serious. More than 20%. Okay? So if you have 20 items, 4 items you can delete. More than 4 items, that's already very serious. Because many respondents didn't understand your question. Okay. Any questions on the reporting? Table number 1. Okay. Next table you will see in many tables is called table number 2. And table number 2 is called discriminant validity. Okay, so this table number 2, I highlight first with a blue, and this is this. Okay, table number 2 is your HTMT, because we no longer use phoneme locker. But if you want to report in your thesis phoneme locker and also HTMT is up to you. But HTMT is a better measure. Okay? So we will report on the HTMT. Yeah? So in your report, we already have this table, right? If you scroll down, you have this discriminant validity. This is the table we need to copy. Okay, this table. Okay, so just copy this table and put it in your Excel first. So in your Excel, we now have another tab called discriminant. And I will place it there. In Excel, it's easier to edit. That's why I like to use Excel first before we copy and paste. So this is the table. If you see these names are very long, right? Very difficult to put them in a portrait form. You can put 1, 2, 3, 4 number them. Number them. 1, 2, 3, 4. And then what you do is you edit here and put a number here. Okay. 1, 2, 3, 4. Okay. So the number 1 is representing complexity, number 2 is adjoining. So we know that. So this is the table you will present next. Okay. Same thing, we will copy, paste in your table like this. Okay, right? Okay, copy and it's here. Okay. The same thing, we will do the formatting first. Push it a bit. This one we can centralize. And highlight the table first, change to table design. Remove the bold and done. Okay, so now the table is ready, right? Yes. In the empty cell here, you put a dark black color, okay, so that it is like this. Yeah? And here, in this cell here, we will put X. So, the same table, we will present at table number 2. And what we are explaining is, these are the 4 things. So first we explain about this premium validity. Then we talk about how do you assess if we have many criteria, like on and after HTMP. For HTMP, we have to use what kind of level criteria. And finally, we will compare with the table. All of them are less than 0.9. We are here. So that's how we will present these 2 tables. After you have these 2 tables presented, okay, these 2 tables tells you that your measures are valid and reliable. Then only you can proceed to the next stage to test the hypothesis. If you don't pass this stage, cannot move forward. Okay? So that's step 1 that you need to pass. The citation is called Anderson and Gerbing. Okay? Anderson and Gerbing. Step number 1 we are doing. Okay. Any questions on the reporting part?
Probably is the last time.
Then it's still a long time ago. Okay. So next is your structural model. You want to present the structural model.
Can go on to the scene. Of the scene.
Okay, next table is called hypothesis testing. This is where we want to record your structural model. So when you go back here. Okay, so this is your measurement model. We already ran the structural model earlier, right? It is actually here. Can you see here? Other result. Do you have other result? Okay, and then there's a bootstrapping. Do you have bootstrapping? Oh, okay. Every time you run, right? They keep on adding. If you run bootstrapping 3 times, they have bootstrapping 1, bootstrapping 2, bootstrapping 3. Okay. Do you have? Okay. I think you have to rerun. For those who have this other result, right? The one you ran earlier is already here. They will list, right? Like if you click here, they give you bootstrapping also. Can you see the bootstrapping? This was what we did earlier. If not, you have to rerun. You have to rerun.
You will remain there, you will close this one.
If you close, you won't be there.
Okay, so it's
You run many times, right? Bootstrapping many times, algorithm many times. They will have 1, 2, 3, 4.
How somebody explain.
Okay, if I run again, balance algorithm, right?
And then.
You see now I have 2. Because I ran 2 times algorithm. You can keep on adding the result.
Okay.
If you want to go back, if you go back to bootstrapping, they will show you result of the bootstrapping. If you go to algorithm, they show you result of the algorithm. Okay, it's still there. Okay, so if you want to rerun, you just run the bootstrapping again. Now you will change the bootstrapping. So in the bootstrapping, first you open the report. Okay, you get a long list of reports, right? Okay, the one we need is this path coefficient. Okay, path coefficient. So when you open the path coefficient, this is the table we need to copy. We have 4 hypotheses. We have 3 hypotheses, right? Let's copy first. And in your Excel, we will create another new tab. Or
Part competition, yeah.
yeah, it's already given with the p-value, path coefficient. Yes. Okay, under the path coefficient p-value, after you copy, when you paste in the column number 2. Paste in column number 2. Column number 1 is hypothesis number. Right click and paste. So you will have a table like this, right? Did you get the table like this?
Yes.
Okay. So we have a summary of the hypothesis. This is the hypothesis, right? Complexity to satisfaction, enjoyment, and usefulness. We have several columns, right? Okay. The first column, we will label the table. For reporting, we will need to label the table. Okay. The first column is called hypothesis.
Hypothesis.
And then you put in the number. Okay. The software follows alphabetical order. Okay. It follows alphabetical order. Your hypothesis may not follow the alphabetical order, right? Maybe your first hypothesis starts with a Z, right? It will be in the last. So you need to number, then you can do sorting. Okay. That's why we need to write the number first. Okay. So according to our model, let's say when you draw your model, right? Your first hypothesis is usefulness, correct?
Yes.
Second hypothesis is complexity. Third hypothesis is enjoyment. But the sequence doesn't follow that. No? So we will go back here. Okay, this is your H1. Okay. Okay, usefulness, complexity, and enjoyment. So complexity is H2, right? And this is H3. Yeah. Later we can do the sorting. Okay, 1, 2, 3. Yeah. Okay. That's why we put the 1, 2, 3. Yeah. Okay. This column called this column. I usually label as relationship. This will be standardized data. This is called standard deviation. This is key value. Key. Okay. This column called sample mean. This column is not needed because when we run the 10,000 bootstrap, every time we run the bootstrap, we have different values, right? Average of the 10,000 value is a sample mean, which is not needed. No? We can delete that column. Sample mean. Okay. For reporting, that is not required. No? This column is not required. Okay. Just right click and delete. No? Okay. For p values which are like this, right? 0, 0, 0. You don't report 0, 0, 0. APA 7 addition is p less than 0.00. No? This is how you report your 0, 0, 0. Okay. Okay. Done? Table? The first, the bottom portion. So there's same format. Okay. So this is what we will report. Okay. Are you still doing this? Are you still doing this? 1 star, 2 star, 3 star? No. Are you still doing this in your reporting? This was many years ago, when the software doesn't give you P value. We put 1 star, 2 star, 3 star. Now we no longer do this. Okay? APA 6 addition and above, you must report P value to 3 decimal place. 3 decimal place. So that's why we are doing this. Okay. Currently, many journal editors don't like P values alone. Because P values will be influenced by sample size. You just keep on increasing your sample size, everything will become significant. So the number given in textbook is 30 to 500, okay, and then 100 to 400, right? You don't see any number greater than that. Okay? So if you want to collect more, you can collect up to 500, okay? Not more than 500. You understand? The G power tells you minimum. Remember 85? You can collect up to 300, 400. No? Bigger sample size will be more representative, but you don't collect 1,000, 2,000. Umar Sekran. 30 to 500 is Umar Sekran, right? Okay. 100 to 400 is a hair. Okay. 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 So this is the first part of the table. So instead of reporting just P value, now they are requiring you to report also the confidence interval and the effect size. Okay, confidence interval and the effect size. Okay, the confidence interval they have already give you in the results. In your results here. So if you open your report, we are now here, right? Part coefficient. This one. Okay, we have 2 interval, right? Can you see 2 interval? This is confidence interval without the correction. We have another confidence interval with the correction, right? This is what we do. If you go here, you will see the lower limit and the upper limit, right? We have 5% and 95%.
Yes.
Why is it 5%, 95%? Is because we are using one tail. One tail. One tail is 90% confident. 2 tail is 95%. It will be 2.5% here, 97.5%. If you run 2 tails, the software will do that. Okay. So this is one tail. We need these 2 columns. Okay. So we copy this, paste beside the table, delete all the columns except the last 2 columns. Okay. The last 2 columns. Okay. Like this. We copy to Excel. In your Excel, we paste it here, right? Click paste. We remove all the columns except the 5% and 95%. Okay. This 5% and 95%, I usually label them as PCILL and PCIUL. PCI is because percentile corrected. Okay, percentile corrected. So how do you know the hypothesis should be significant? Lower limit and the upper limit should not straddle a 0. Should not straddle a 0. That means your lower limit is negative, upper limit negative, no 0 in between. Lower limit is positive, upper limit is positive, no 0 in between. Then they are significant. If your lower limit is negative, upper limit is positive, what it means is there's a 0 in between. Okay? 0 in between. If 0 in between means no relationship. And that's why it should not have a 0 straddling or lower and upper limit. That's the criteria. Okay? Like this. When you draw your normal curve, right? Okay. If your lower limit and the upper limit is here, right? All the time is positive, right? All the time is positive. We can also have like this. What the lower limit and the upper limit is negative, right? All the time they are significant and negative. But if you have like this, okay, sometimes it's negative, sometimes it's positive, sometimes it's 0. 0 means no relationship. And that's why you should not see a zero in between. Straddling a zero. Here both of them are positive, positive or negative, negative. Okay. The last value we need is called the effect size. Okay, the effect size. So the effect size, if you run the full bootstrapping, they will give you here F square. Can you see the F square? This column. Okay, this number. We just copy and paste and then retain this one, throw this one and this one. Then you can complete the table. Or you can write it down. Effect size F square.
Square.
Just copy and paste it just beside us. And we will delete this and delete the rest. Okay, so now we have a full table, right? Okay, this is how you can present your report with p-value, confidence interval, and effect size. Okay. And all three converge, right? P-value is significant. Confidence interval no zero. And this one, they are all more than 0.02. So this one we can put 2 decimals.
How come my S square is not there?
Okay, I repeated this, right? When you run your bootstrapping, you must run the complete. If you don't run the complete, they will not give you F square. It will give you in your algorithm. Run again the bootstrapping with the complete.
We have the 3
But for effect size, you can use 2 because the common gives you 0.02, 0.01, 0.15, right? So we can compare. Okay, so this is how we can report a full structural model in papers or thesis. Okay, any questions on the reporting? Okay, so this is how you see in more recent papers, they have started using this format for reporting. No? R square we discussed in the text. Okay, if you write a paper, you don't report R square, I will reject. Because if you don't see the R square, we don't know how good is your model.
Why not in table?
No, I don't put them in the table anymore. Very confusing, because if you have independent, mediator, dependent, some will have R square, some no R square. And then we have confusion, some reviewers will ask, why some R square, some no R square. I stopped reporting them. So, experience. Previously, I have R square in the model, right? So I removed. Because if you have 3 independent, 1 mediator, 1 dependent, right? Only 1 R square, the other 2 columns will be empty, right? And then they ask, how come we have 1 R square, not 3? Okay, I had that experience, so I removed them from the table. Text in the text only I discuss.
How come I only have 1 row?
One row what?
1 row.
One row what? No. I'll calculate. Running bootstrap. Okay.
Or maybe I need to step. So
Okay, just expectation. Square. Square.
Some dogs.
Okay, for reporting, this is the final report you will do lah. Any questions on the reporting part? Okay. Next, I want to show you another reporting called PLS predict. Okay. We have two prediction now. We will do. Number one is called PLS predict, which is predicting the item. The new one is called CVPAT. Cross-validated predictive ability test. That one will predict the construct. Okay? We are supposed to predict the construct, not the item. But previously, we don't have that procedure. So now they have already introduced in 2021, I think. But unfortunately, many people don't report that. They thought it's not there, but it's already in the software. Okay? So before we run the procedure, one of the requirements for this analysis is n divided by k. This k is called how many times you want to fold your data. So the software developer, they suggest any number from 5 to 10 or 5 to 12, any number. The only requirement is your sample size divided by the k must be greater than equals 20. This is the first requirement. Okay? N divided by k cannot be a round number.
Even.
No, it's called integer, cannot be a round number. Okay, let's say my sample size is 200. Okay? I divide them 10 times. Okay, 200, right? 200, I divide 10. Can we use 10? Okay, the first one, okay. Second one, okay. So round number. 200 divided by 10 is 20. 20 is a round number, cannot. Okay, so I can change it to 9. Okay, 9 can, right?
Is there any calculation for the Q? Is it Q the same side probability 70?
No. This one we are saying I want to split the data into multiple samples. Okay, but when you split the data, one sample must have at least 20 samples. Okay. So if the sample size is 200, you divide by 10, you get 20 unique samples. But 20 is a round number. Cannot.
What's the purpose of doing this?
This one we have to do prediction. Can we predict the item and the construct? Previously, we don't have the prediction for construct. We have only for item. So that's why everybody until now they are reporting the item. But the software already has prediction of the construct. But unfortunately, many people don't know. So we are still reporting, and there's a recent systematic review, and they found only 2 papers reporting CVPAT. Although it's already 4 or 5 years old. So now they're suggesting maybe you want to look at CVPAT. That is predicting the construct. Okay, remember, we have independent, dependent here. Okay, when you draw your model, you are predicting this variable, right? You're predicting this variable, right? You're supposed to predict the construct, right?
Yeah.
But now you're actually doing the item. Currently, okay? That's why they're saying, why are you not predicting the construct? Okay? So now we can do both. So you have an option now. I prefer to do the construct, not the item. Because the prediction is predict the construct, your dependent variable, right? Not the item, but previously we don't have that procedure. That's why we were doing the item. But now we already have the construct level.
And under what consensus we normally do?
Because when we do PLS, we are doing prediction, remember? But we didn't show this. And that's why now the literature is saying, you claim you are doing prediction, where did you show? How good is your prediction? Okay? So that's why we need to do this. This is the paper written by this lady. So I will show you. Her name is Galit Samuel. she actually developed this tool called PLS Predict. Okay, so what PLS Predict does is they will split the data into whole out sample and analysis. If you see here, how many of you are from some background in finance or econometrics? Okay, this is what we call as training sample and whole out sample. In finance, they have in sample, out of sample testing. You develop your model using your data, then you have an equation, you need to predict new data. That is called out of sample. So the idea is actually from that area, forecasting. Okay, so we are supposed to collect data 2 times, but this is nearly impossible in our area. So what they are saying is we collect data first, we split the sample randomly. Okay, so this first 200 we use for your modeling. We use the equation to predict the next 200 we keep up. This 200 is the whole lot. Okay, so we will have an equation like this. From this data, we get this equation, right? Remember? We develop the equation. Okay. Regression equation.
Yeah.
Okay. What we do is after we develop this equation, we will take the x1, x2, x3 and plug into this one. Then you have a y hat. Y hat is a predictor. You already have the actual y. Actual y is there. This is your predictor y. There will be some difference, right? If the difference is small, means your prediction very good. If the difference is big, means no good. That's the idea. But what we are doing is we develop the equation with the same data. We are predicting the same data, which is not prediction. That's why they are claiming this is not the way. We need to use new data. So we already have the 200 here, right? Which we didn't use. We didn't use, right? We have the x1, x2, x3, right? We will take this and put into this equation. We already have the y here, remember? You get a predicted y, right? We take the predicted y minus this y, which is not in the model. That is out of sample. Okay, out of sample. So we will calculate the measure, the error, the residual, right? So we have RMSE and MAE. This is from forecasting. So if the difference is small, that means your prediction is good. If the difference is big, means no good. That's the basic idea of this prediction. Okay? So up to 2017, we didn't have 2019, we didn't have a guideline paper. Okay? So this paper was published in 2019. One of the authors is from Malaysia. This is, okay, if you see the paper submitted on the same day, revised on the same day. Submitted on the same day, revised on the same day. 7 days later, it was online. So the associate editor of the journal came to visit me in Penang. So I asked her a question. How come you accepted this paper so fast? And she has two answers. One, she said, look at the authors. Look at the authors. You have hair in the. Okay? The second reason is this paper will generate lots of citation. Okay? And currently, this is the most highly cited literature in that journal. Because everybody who use PLS physics will cite this paper. Why? Because they give you very nice diagram. Can you see the diagram? Easy to follow, right? Okay. They give you this two. We have two criteria. They will give you RMSE and MAE. Okay. If your data, your errors are normally distributed, we will use this. If your errors are not normally distributed, we can use this. But for those who are easily confused, no need to look at it. Just use RMSE. Because later you see the drawing also, you don't know normal, not normal, right? So just use this criteria. Okay. Next is the difference. So here it tells you, check if PLSM error is smaller than linear model. This is the benchmark. So previously we have only one benchmark. Now we have another benchmark called IA, indicator average. So they will give you two benchmarks. So if your errors of your PLS is smaller than these two benchmarks, then your prediction is very good. That's the basic idea of this. So how do you decide it's good, not good? When you take your PLS minus the linear model, if you get negative, means this is smaller than this, right? Minus. This minus this, you get a negative sign. This is smaller than this. Okay. So if all minus, you are here. All the item minus, you are here. If all the items positive means no good. Your prediction is no good, right? Okay. In between, we have a majority and minority. A majority means 50% or more. Minority is less than 50%. Okay, that's how you decide. Huh? So this is an example given by here. Okay, they will give you this RMST and MAD side by side. Huh? This is for the PLS model. This is for the linear model. Okay? So if you take the RMST criteria, right? All these are smaller than this. All these are smaller than this, right? Then you have strong predictive power. Okay? If you take the MAE criteria, 2 out of 3. This becomes majority. 2 out of 3, right? So that's why don't use both. Now you have to pick one to report. Okay, to report. Now, so up to I think April, no, up to April, June, I think May, June, they only had one criteria called LM. No? Now they introduced a new one called IA, indicator average. Okay? Indicator average. Indicator average is easier to pass. Linear model more difficult to pass. Okay? That's why they are giving you both now. Huh? So when you run the model, again, this is our model, right? Okay. When we run this model, we want to predict this for first. Huh? Later I told you for the fun. Currently we want to predict this for, right? Okay. When we run this model, we can go calculate this one. Huh? Here let's predict. Can you see the slide? This is item. This is function. Okay. We are given both. Huh? So this is where we need to pick the number. Can you see the number here? Okay. So ours is 191. Remember? Sample size cannot divide by 10. Because 191 divided by 10 is 19. Not enough. Huh? So we can divide by 9. Or 8 or 7. You can do some calculation. Huh? As long as each fold is more than 20, not a round number. Not a round number. Huh? So we can try with 9. Huh? We can change this to 9. Okay. What is meant by a fold is you split the data 9 times. Okay. R is how many times you run. You run 9 times. Okay. So this is how they run the model. Huh? So I show you it. And it, so each one K is 5, repetition is 5, right? The first round, they keep this 20, they run with the 80. Okay? The second round, they keep this 20, not this one. So every time they different fold is removed. Then you can calculate the average error that you find. So this is the process they run. The software will run it for you. So you need to decide on how many times you want to run it. Okay? So after you run this analysis, we already picked 9 times, right? So what will happen is they repeat the analysis 9 times.
So the repetition follow the same.
Usually they recommend to follow the number. The software developer.
Under the person who came up with this idea.
You can look at there are some explanation here. Can you see here? You can click here and see the explanation. Here. That's why I asked you to be curious. There are some here, right? Can you click here and see? They give you some explanation, right?